Hello there, and welcome to Science for Sleep. Where curiosity slows down for the evening, the universe feels a little quieter, and science becomes something soft enough to drift away to. Tonight, we're travelling far beyond the familiar planets of our solar system and into a realm that often hides in their shadows, a place filled with frozen oceans, endless volcanoes, methane rainstorms, wandering ice worlds, and moons so strange they almost seem invented by science fiction writers who had too much coffee and far too much imagination. Because when most people think about space, they think about planets first. Jupiter, Saturn, Neptune, maybe Mars if they're feeling optimistic about future vacations. But the planets themselves are only part of the story. Orbiting around them are entire worlds that rarely get the spotlight. Quiet companions circling through darkness, some larger than planets, some warmer than expected, some colder than anything we can truly imagine. Tiny worlds and giant ones alike, each carrying its own strange personality across billions of kilometres of empty space. And the surprising thing is this: some of the most extreme places we have ever discovered are not planets at all. They're moons. Moons with oceans hidden beneath miles of ice. Moons where volcanoes erupt so violently that material blasts hundreds of kilometres into space. Moons with thick orange atmospheres and lakes made not of water, but liquid methane. Moons that tumble chaotically like uneven potatoes thrown through the cosmos by an invisible hand. Moons that may one day become the first places where humanity discovers life beyond Earth. Which is a rather ambitious resume for objects that many of us barely remember from school diagrams. And perhaps that's part of what makes them so fascinating. They sit quietly beside their planets, like supporting actors in a cosmic film, while secretly being far stranger than the stars of the show. So tonight, we're going to slow down and wander among them together. We will drift through the volcanic skies of Io, descend beneath the frozen crust of Europa, float over the hydrocarbon seas of Titan, and travel into regions of the solar system where sunlight is little more than a pale memory. Along the way, we'll encounter worlds that challenge almost everything we expect planets and moons to be. Some are warm when they should be frozen, some are active when they should be dead, some may have conditions suitable for life despite existing unimaginably far from the comforting heat of the sun. And somewhere during all of this, while your mind begins to settle and your thoughts soften into that pleasant half-dreaming state between curiosity and sleep, you may start to notice something else. The universe is far less orderly than we once believed. It is messy, creative, sometimes deeply unreasonable. One moon is covered in sulfur and lava fountains. Another hides an ocean beneath ice thicker than mountains. One rotates in the wrong direction entirely, as though it ignored the instructions and decided to orbit backward out of sheer stubbornness. There are moons shaped like walnuts, moons shaped like eggs, and moons so lightweight and porous that they resemble giant floating sponges more than solid worlds. Space, it turns out, has absolutely no obligation to behave normally, and honestly that feels oddly comforting, because here on Earth, we spend so much of life trying to organise things neatly. Calendars, schedules, emails, grocery lists. We label drawers. We colour-code folders. We set alarms we fully intend to obey and then ignore with tremendous dedication the next morning. But the universe itself seems much less interested in tidiness. It builds worlds through collisions, gravity, chaos, heat and accident. And somehow, out of all that disorder, astonishing places emerge. Before we continue drifting farther outward though, I'd love to ask you something. Where in the world are you listening from tonight? Maybe you're lying in bed while rain taps softly against a window. Maybe you're under blankets with headphones on while the rest of the house sleeps. Perhaps it's late evening where you are, or early morning, or one of those strange hours where time feels blurry and the world grows unusually quiet. And what time is it in your little corner of Earth right now? Funny, isn't it? At this exact moment, while we talk about distant moons circling, Giant planets millions or even billions of kilometers away, all of us are also riding through space together on our own moonlit world. Earth itself spinning silently beneath us at more than 1,600 kilometers per hour near the equator, while the moon hangs nearby like an old familiar companion we've somehow managed to take for granted. In fact, that's another curious thing about moons. We grow up with one overhead so consistently that it almost stops feeling mysterious. It's simply there, a pale shape in the sky, sometimes full, sometimes crescent, sometimes hidden. It pulls the tides, lights the night, inspires poems, songs, calendars, myths, werewolves, questionable late-night decisions, and an impressive amount of human staring. But once astronomers began discovering other moons throughout the solar system, our own suddenly seemed less lonely and far less typical. Some moons are bigger than Mercury. Some have atmospheres thicker than Earth's. Some produce enough internal heat to stay geologically alive billions of years after they should have cooled. One moon around Saturn sprays giant plumes of water vapor into space like an enormous icy geyser. Another around Jupiter may contain more liquid water than all Earth's oceans combined, hidden beneath a frozen shell. And then there are moons orbiting far beyond Neptune in darkness so deep and cold that the sun would appear only as an unusually bright star in the sky. If you stood there, sunlight would barely warm your face at all. Not that standing there would be particularly relaxing. You would freeze very quickly. Still, even in those distant frozen regions, these worlds continue their endless journeys around their planets, silent, persistent, ancient. Many formed alongside their planets billions of years ago during the chaotic early days of the solar system, when collisions happened constantly and giant worlds pulled smaller objects into orbit, like cosmic fishermen dragging in strange catches from the dark. Others may have been captured later, stolen from elsewhere and trapped by gravity forever. That means some moons may actually be refugees from entirely different parts of the solar system. And the deeper scientists looked, the stranger things became. At first, moons were expected to be fairly dull. Dead rocks mostly, cold leftovers orbiting more important worlds. But spacecraft flybys kept revealing surprises. Voyager, Galileo, Cassini, New Horizons. Each mission peeled back another layer of expectation and replaced it with something weirder. Io turned out to be the most volcanically active world ever discovered. Europa appeared smooth and cracked, hinting at a hidden ocean underneath. Titan possessed rivers, clouds, and rain. Enceladus blasted water into space from beneath its icy crust. Even tiny moons, no larger than cities, displayed bizarre shapes and unusual behaviours that no one fully predicted. Again and again, the solar system refused to be boring, and perhaps one of the most remarkable things about these discoveries is how recent many of them are. For almost all of human history, we knew only our own moon. That's it. One lonely satellite hanging above Earth while the rest remained invisible. Then, in 1610, Galileo Galilei pointed a telescope toward Jupiter and noticed 4 tiny points of light moving beside it night after night. Those moons, now called Io, Europa, Ganymede and Callisto, changed astronomy forever, because suddenly Earth was no longer unique. Not everything revolved around us. Other worlds had companions too. Imagine how strange that realization must have felt. Human beings had spent thousands of years looking at the night sky with naked eyes, constructing stories about gods and monsters and cosmic order. Then one man looked through a tube with bits of shaped glass inside and discovered entire worlds hiding in plain sight. Tiny moving dots. That was all it took to change humanity's understanding of the universe. Since then, we have found hundreds of moons in our solar system alone, and likely countless more around planets orbiting distant stars. Some are only a few kilometers across. Others rival planets in size. A few are so complex that scientists now consider them among the most promising places to search for extraterrestrial life. which is quite an upgrade from minor satellite, and yet despite all these discoveries, our moons still feel oddly intimate compared to planets. Perhaps because they orbit something larger. They feel companionable somehow, less isolated, a bit like cosmic travellers keeping close company in the dark. Our own moon certainly shaped human life profoundly. It stabilised Earth's tilt, influenced tides, guided calendars, illuminated ancient nights, and may even have helped create conditions stable enough for life to flourish here. Without the moon, Earth itself might have become wildly unstable over geological time, with dramatic climate swings making complex life far more difficult. So even the simple existence of moons can transform entire worlds. And elsewhere in the universe, that process may be happening again and again around distant planets we have not yet even seen clearly. Right now, somewhere out there, another moon may be circling a giant planet beneath alien clouds, while oceans move beneath its crust in complete darkness. There may be storms there, ice, heat vents, chemical reactions quietly unfolding beneath buried seas, possibly even life. Not cities or spaceships, perhaps. Not little green aliens building moon hotels and arguing about parking regulations. More likely something simple. Tiny organisms drifting through dark oceans beneath frozen ceilings, existing entirely unaware that another species on a distant blue world lies awake at night wondering whether it is alone. And honestly, the universe becomes much more interesting once you realise life may not require warm, sunny surfaces at all. For a long time, scientists assumed life needed something Earth-like. Sunlight, moderate temperatures, liquid water on the surface, nice conditions, preferably with tolerable weather and minimal asteroid impacts. But moons like Europa and Enceladus changed that thinking dramatically. They suggested that tidal forces, gravity itself flexing and squeezing worlds internally, could generate enough heat to maintain hidden oceans beneath ice. That means life might survive in darkness, not because of sunlight, but because of chemistry and geothermal warmth deep below frozen crusts. A strange idea, a little unsettling, also incredibly exciting, especially when you remember that icy moons may be vastly more common than Earth-like planets, which means the universe could potentially be filled with hidden oceans quietly existing beneath ice shells across countless star systems. Entire dark ecosystems beneath frozen ceilings. The cosmos suddenly feels much less empty when you think about it that way. Of course, space is still spectacularly hostile overall. Let us not accidentally romanticize standing on an airless, radiation-blasted moon, where your blood would boil inside an exploding spacesuit. Many of these worlds are extraordinarily dangerous. Temperatures plunge hundreds of degrees below freezing. Radiation near Jupiter is powerful enough to destroy electronics rapidly. Some moons experience massive tidal stresses that crack their surfaces continuously. These are not gentle places, they are extreme places, and that is exactly why they fascinate us. Human beings have always been drawn toward extremes. Deep oceans, high mountains, polar ice, deserts, volcanoes, storms. Somehow the harshest environments awaken curiosity most strongly. Perhaps because they remind us how large reality truly is compared to our comfortable daily routines of laundry, traffic lights, coffee mugs, and trying to remember passwords we've definitely used before. The moons of the solar system expand that perspective enormously. They remind us that entire worlds exist beyond our ordinary imagination. Worlds where methane falls as rain. Worlds where ice behaves like rock. Worlds where underground oceans may stretch farther than anything on Earth. And tonight, as we slowly travel among them together, we'll meet some of the strangest examples ever discovered. Because once you leave Earth behind and begin wandering through the outer solar system, normality disappears very quickly. Long before human beings understood what moons actually were, we filled the night sky with stories about them instead. Some cultures imagined them as gods, others saw spirits, lanterns, wandering eyes, or silent guardians watching over the Earth after sunset. Ancient astronomers tracked their movements carefully, noticing patterns long before they understood gravity, orbital mechanics, or planetary formation. And honestly, you can hardly blame them. Even now, thousands of years later, moons still feel oddly personal compared to other objects in space. Planets seem distant, stars feel unreachable, but moons somehow appear familiar. Perhaps it's because we grow up with one overhead. The moon becomes part of ordinary life before we even understand what it is. You see it through car windows as a child and briefly become convinced it's following you specifically. You notice it hanging above winter streets or reflected in puddles after rain. Sometimes it appears enormous near the horizon for reasons your brain insists are magical, even though science patiently explains otherwise. And somewhere along the way, the moon stops being an object and becomes part of the background rhythm of life itself, which makes it easy to forget just how strange moons actually are. Because when you step back and think about them carefully, moons are a little peculiar. Entire worlds circling other worlds, some tiny, some enormous, some nearly planet-sized, all locked into endless motion by gravity. They accompany planets through darkness like cosmic travelling companions, each relationship slightly different from the next. Some orbit peacefully and regularly, others tumble chaotically, a few may not even belong where they are at all. And the deeper astronomers looked into the solar system, the more they realised moons are not rare side decorations attached to planets almost as an afterthought. They're fundamental parts of how planetary systems evolve. In many cases, moons help shape the destinies of planets themselves. Earth's moon certainly does. Without it, our world might be dramatically different. Earth's tilt would wobble much more unpredictably over long periods of time, potentially creating severe climate instability. Seasons could shift chaotically over millions of years. The tides would be weaker, nights darker. Early life along coastlines may have evolved differently. It is entirely possible that complex life on Earth owes part of its success to the quiet gravitational influence of the moon, which is slightly humbling when you realise our closest celestial companion may have helped create the stable conditions that eventually allowed human beings to invent alarm clocks, microwave burritos, and online arguments about whether pineapple belongs on pizza. Cosmic history works in mysterious ways. Still, for most of human history, nobody knew where moons came from. They simply existed, hanging overhead or drifting beside planets through telescopes. But modern astronomy eventually revealed that moons can form in several completely different ways, and each method tells its own story about chaos, collisions, and gravity. Some moons are born alongside their planets, others are captured. A few are the surviving wreckage of catastrophic impacts. And all of these processes begin in the same place, the early solar system, a time when nothing was calm, organised, or remotely peaceful. Around 4.6 billion years ago, the solar system looked less like a tidy arrangement of planets, and more like a giant swirling disaster zone filled with dust, gas, rocks, and collisions happening constantly. The young sun blazed at the centre, while material spun around it in a massive disk called the protoplanetary disk. Inside this rotating chaos, particles began sticking together through countless impacts. Dust became pebbles, pebbles became rocks, rocks became mountain-sized objects. Eventually gravity took over more aggressively, pulling larger bodies together into protoplanets. Unfortunately, the process was not elegant. Imagine trying to build a delicate sculpture by throwing bricks into a tornado and hoping gravity sorts everything out eventually. That is roughly how planets formed, and moons emerged naturally from this same violence. One common way moons form is through co-formation. In this process, a young giant planet gathers material around itself while forming, creating a miniature disk similar to the one surrounding the Sun. Inside that smaller disk, moons begin assembling from leftover gas and debris just as planets formed around the star. Jupiter's large moons likely formed this way. So did many of Saturn's. tiny solar systems orbiting giant worlds, and honestly, Jupiter especially starts to resemble a failed star hosting its own little family of worlds once you look at it that way. Its largest moons are enormous. Ganymede, for example, is larger than the planet Mercury. If it orbited the Sun directly instead of Jupiter, early astronomers might easily have classified it as a planet. Instead, it circles a giant gas world once every 7 days like an obedient cosmic companion. Though obedient may not be entirely accurate because gravity creates surprisingly dramatic relationships between moons and planets. Take tidal forces, for instance. On Earth, tides seem fairly gentle. Oceans rise and fall gradually under the moon's gravitational pull, pleasant enough from a distance. Sometimes inconvenient if you're carrying picnic equipment across a beach at the wrong time. But in the outer solar system, tidal forces become far more extreme. Jupiter's gravity squeezes some of its moons relentlessly, literally squeezes them. As moons orbit giant planets, gravity stretches and compresses them repeatedly. Their interiors flex continuously, generating enormous amounts of heat through friction. This process, called tidal heating, can transform what should be frozen dead worlds into geologically active places. Io is the perfect example. It orbits Jupiter so closely that the giant planet's gravity constantly deforms it. Imagine squeezing a stress ball over and over again for billions of years. Eventually things heat up. In Io's case, they heat up enough to create the most volcanically active world in the entire solar system. Not Earth, not Venus, a moon. All because gravity refuses to leave it alone. And this same process may keep oceans liquid beneath icy crusts elsewhere. Europa and Enceladus probably maintain hidden subsurface seas, thanks largely to tidal heating. Without gravitational flexing, those oceans might freeze solid completely. So moons are not merely passengers orbiting planets. They interact with them dynamically. Sometimes dramatically, sometimes violently, sometimes in ways that may create environments suitable for life. Then there are captured moons, which are perhaps even stranger. These are objects that likely formed elsewhere before wandering too close to a giant planet and becoming trapped by gravity. Neptune's moon Triton is one of the best examples scientists have found. It orbits backward compared to Neptune's rotation, strongly suggesting it did not originate there naturally. Instead, Triton may once have been an independent object drifting through the outer solar system, before Neptune captured it long ago. Imagine being a wandering icy world moving silently through darkness for millions of years, only to suddenly find yourself trapped forever around a giant blue planet. Not exactly an ideal travel experience. Though admittedly better than colliding directly with Neptune at high speed, captured moons help explain why some satellite systems look strangely irregular. Many giant planets possess clusters of tiny moons, with tilted, elongated or backward orbits. These objects often resemble captured asteroids or Kuiper belt objects, rather than neatly formed companions. The solar system, it turns out, is full of stolen worlds. Gravity is surprisingly possessive, and occasionally catastrophic. Because another major way moons form involves giant impacts, immense collisions between planetary bodies capable of reshaping entire worlds. Earth's moon likely formed this way after a Mars-sized object called Theia collided with the young Earth billions of years ago. The impact was unimaginably violent. Material blasted into orbit around Earth, eventually gathering together into the moon we know today, which means our nearest celestial companion may literally be made partly from Earth itself. A fragment of planetary wreckage transformed into something stable and beautiful over billions of years. There is something strangely comforting about that. The moon feels permanent now, calm and familiar overhead, but its origin was catastrophic beyond comprehension. Entire oceans of molten rock, vaporized crust, debris encircling the Earth like a glowing ring before slowly coalescing into a world, and eventually somehow moonlight reflecting onto quiet forests and sleeping cities. Cosmic violence often produces unexpected beauty. Saturn's rings may represent another example of destruction creating elegance. Some scientists suspect they formed from shattered moons torn apart by gravity after drifting too close to the planet. Even beauty in space can begin as disaster. Still, moons do more than simply orbit their planets. Over long periods, they can stabilize worlds, alter climates, affect atmospheres, generate tides, and even influence the possibility of life itself. Our moon stabilizes Earth's axial tilt. Charon locks Pluto into a strange gravitational dance, where both worlds always face one another. Some moons generate magnetic interactions with their planets powerful enough to create radiation belts and auroras. Others slowly drift away from their planets over time. In fact, our own moon is gradually moving farther from Earth every year by about 3.8 centimeters annually. Not much, admittedly. Roughly the speed of fingernail growth. Cosmically speaking, though, it means the Earth-Moon relationship changes slowly over time. Hundreds of millions of years ago, the moon appeared much larger in the sky, and Earth's days were shorter. Tides were stronger too. Dinosaurs lived beneath a slightly different moon than we do. And far enough into the future, total solar eclipses may stop happening entirely because the moon will appear too small in the sky to fully cover the sun, which feels unfair somehow considering how spectacular eclipses are. The universe can be surprisingly rude about these things. Then again, moons themselves are often temporary on cosmic timescales. Some spiral inward toward destruction, others drift outward, some eventually collide with their planets or break apart into rings. Stability in the universe is often more fragile than it appears. Even planetary systems evolve continuously. And once astronomers began searching beyond our solar system, the question naturally emerged: do exoplanets have moons too? Almost certainly, though detecting them is extremely difficult. Moons are already relatively small objects compared to planets, and exoplanets themselves are often tiny faint shadows against distant stars. Trying to identify moons around those planets becomes an extraordinary technical challenge. Still, astronomers have found possible evidence for enormous exomoons orbiting alien worlds far beyond our solar system. Entire hidden populations of moons likely exist throughout the galaxy. Some may resemble those we know, others may be far stranger. Imagine moons orbiting giant planets inside binary star systems where two suns cross the sky. Moons with global oceans hundreds of kilometers deep. Moons heated not by stars but by powerful tidal forces. Moons drifting freely through interstellar space after being ejected from their planetary systems entirely. Rogue moons wandering alone between the stars. The universe appears remarkably willing to create almost every possibility eventually. And perhaps that is why moons fascinate scientists so deeply now. They are no longer seen merely as secondary objects attached to more important planets. They are worlds in their own right. Complex, active, dynamic places capable of surprising us repeatedly. Some may harbour life. Some may preserve clues about the formation of the solar system itself. Some may one day become destinations for robotic probes or even human explorers. In fact, several future space missions focus heavily on moons specifically. NASA's Europa Clipper mission aims to study Europa's hidden ocean in detail. The European Space Agency's JUICE mission will investigate Jupiter's icy moons as potential habitats. Scientists are increasingly treating moons not as curiosities, but as some of the most promising places in the search for extraterrestrial biology. And honestly, once you start learning about them, it's difficult not to become slightly attached. There is something appealing about worlds that exist in reflected light. Moons do not generate their own illumination. They travel through darkness beside larger companions, quietly shaping and being shaped by gravity over immense spans of time. They survive impacts, radiation, freezing temperatures, and orbital chaos while continuing their endless revolutions with remarkable persistence. Quiet companions of the cosmos indeed. Among all the moons in the solar system, one stands apart immediately as perhaps the most violent and restless place ever found orbiting a planet. A world where the ground constantly tears open beneath giant eruptions, where lava floods enormous plains, and where volcanic plumes rise so high they can be seen from space. And compared to the calm silver moon hanging over Earth tonight, Io feels almost impossibly alive. If you could somehow stand safely above the surface of Io without being instantly cooked by radiation, frozen by vacuum, or launched sideways by an inconvenient volcanic eruption, the first thing you would probably notice is the colour. Not the gentle grey colour we associate with our own moon. Not icy white like many outer solar system worlds. Io looks almost unreal. Yellow, orange, black, red. Great stains and patches spread across its surface like spilled paint on a cosmic canvas. Sulfur compounds coat enormous regions of the moon, giving it the appearance of something halfway between a pizza left too long in the oven and an industrial chemistry accident visible from space. And beneath all that colour, the surface never truly rests. Volcanoes erupt continuously across Io. Lava floods plains. Giant plumes blast material hundreds of kilometres upward. Entire landscapes reshape themselves over relatively short periods of time. Compared to most moons, which tend to be old, cold and heavily cratered, Io feels astonishingly active, restless, almost angry, which is not generally how people imagine moons behaving. For a long time, astronomers assumed moons should be geologically dead. Small worlds cool quickly. Without enough internal heat, their surfaces eventually freeze into stillness, while impacts slowly accumulate over billions of years. That expectation made sense because our own moon fits the pattern fairly well. Its major volcanic activity ended long ago. Most of its surface has remained relatively unchanged for immense stretches of time. Then scientists finally got a close look at Io. And the moon responded by metaphorically setting the room on fire. The discovery happened in 1979 when NASA's Voyager 1 flew past Jupiter and its moons. At first, researchers expected Io to be another cratered icy object. Instead, the spacecraft revealed a surface unlike anything previously seen in the solar system. Active volcanoes, dozens of them, possibly hundreds. One image even captured a volcanic plume erupting into space during the flyby itself. Material blasted upward more than 300 kilometers above the surface, creating a gigantic umbrella-shaped cloud visible against the darkness beyond. Nobody had ever seen anything like it on another world before. Suddenly Io transformed from a tiny point of light beside Jupiter into the most volcanically active place ever discovered. And honestly, it remains difficult to overstate how extreme this moon truly is. Earth certainly has powerful volcanoes. Eruptions can devastate landscapes, darken skies, and reshape entire regions. But Earth's volcanism is relatively moderate compared to Io's relentless activity. On our planet, tectonic plates move slowly across the surface while heat escapes gradually from the interior. Io does not believe in moderation. Its volcanoes erupt constantly because the moon itself is being tortured by gravity. Literally tortured. Jupiter's immense gravitational pull stretches and squeezes Io continuously as it orbits the giant planet. The moon travels on a slightly elliptical orbit, meaning its distance from Jupiter changes slightly during each revolution. As Io moved closer and farther away, Jupiter's gravity flexes the moon over and over again. Imagine bending a paperclip repeatedly. Eventually it heats up. Now imagine that process happening to an entire moon. The constant flexing generates enormous internal friction and heat. Deep inside Io, rock partially melts into magma, fueling endless volcanic activity across the surface. Scientists call this process tidal heating, and on Io it operates with astonishing intensity. The moon essentially lives inside a permanent gravitational stress workout. and Jupiter is not working alone. Neighbouring moons Europa and Ganymede also influence Io gravitationally, helping maintain its elliptical orbit. Without them, Io's orbit might eventually become more circular, reducing tidal heating over time. Instead, the three moons remain locked in an orbital resonance that continuously pumps energy into Io's interior. A complicated cosmic arrangement resulting in one moon becoming permanently volcanically unstable, space can be strangely specific about its chaos. The result is a world covered in lava lakes, giant calderas, and volcanic plains stretching across vast regions. Some eruptions release lava hotter than anything commonly found on Earth today. Temperatures in certain flows may exceed 1,600 degrees Celsius, hot enough to melt many types of rock completely. And because Io has almost no atmosphere, volcanic plumes behave differently there too. Instead of drifting through air currents, erupted material follows graceful ballistic arcs through vacuum before falling back onto the surface. Volcanic snow, in a sense, though considerably less relaxing than the phrase suggests. The surface changes so rapidly that impact craters remain surprisingly rare. Throughout most of the solar system, moons preserve ancient scars from billions of years of asteroid impacts. Craters accumulate slowly because geological activity is limited. But Io continuously repaints itself with lava and volcanic deposits, erasing old impacts before many can remain visible for long. It is one of the youngest looking surfaces in the solar system, despite the moon itself being billions of years old. An ancient world trapped in continuous renewal. And then there are the lava lakes. One in particular, called Loki Patera, stretches roughly 200 kilometers across and may contain a gigantic crust of solidified lava floating atop molten material beneath. Scientists believe sections of this crust periodically sink and overturn, exposing fresh magma below and causing dramatic brightening events visible even from Earth-based telescopes, which means astronomers can literally watch volcanic changes happening on another moon hundreds of millions of kilometers away. Again, a sentence that would have sounded absolutely absurd for most of human history. Io itself is roughly the same size as Earth's moon, but the similarities end quickly after that. Instead of quiet grey plains, its surface resembles a constantly shifting volcanic wasteland. Sulfur dioxide frostcoats portions of the landscape. Mountains rise dramatically despite the lack of plate tectonics. Some peaks tower higher than Mount Everest, and unlike Earth, where volcanoes cluster along tectonic boundaries, Io's eruptions appear scattered almost everywhere. The entire moon behaves like one giant volcanic system. Its atmosphere, if it can even comfortably be called one, is extremely thin and composed mostly of sulfur dioxide gas released from volcanic eruptions. During Io's daytime, sunlight warms frozen sulfur compounds enough for gas to accumulate temporarily. At night, temperatures plunge and portions of the atmosphere collapse back onto the surface as frost. So the moon's atmosphere partially freezes and falls to the ground every single day, which feels slightly excessive even by outer solar system standards, and hovering above all of this is Jupiter itself, huge, overwhelming, dominating the sky constantly. From Io's surface, Jupiter would appear enormous, many times larger than the moon appears from Earth. Its swirling cloud bands would stretch across the heavens, while radiation trapped inside the giant planet's magnetic field bombards Io relentlessly. That radiation environment is one of the most dangerous in the solar system. Jupiter's magnetosphere accelerates charged particles to tremendous energies, creating intense radiation belts around the planet. Io orbits directly inside this hazardous region, receiving enough radiation to destroy unprotected electronics rapidly and kill humans very quickly. So although the scenery might briefly impress tourists, it would not support particularly long vacations. The moon also contributes material to Jupiter's magnetosphere itself. Volcanic eruptions eject sulfur and oxygen particles into space, where they become ionized and trapped by Jupiter's magnetic field. This creates a giant donut-shaped plasma torus surrounding the planet along Io's orbit. In other words, Io is volcanically feeding Jupiter's space environment continuously. The Moon and planet remain deeply connected through gravity, magnetism, and constant particle exchange. A surprisingly intimate relationship for objects separated by hundreds of thousands of kilometers. And yet, despite how violent Io appears, scientists find it incredibly valuable because it demonstrates how dynamic moons can become under the right conditions. Before Voyager's discoveries, few expected such intense geological activity on a moon. Io shattered assumptions about what small worlds could do. It also helped scientists think differently about habitability elsewhere. Now, to be clear, Io itself is almost certainly hostile to life as we know it. The surface environment is extraordinarily extreme. Radiation levels are brutal. Temperatures vary dramatically. Volcanic eruptions constantly reshape the landscape. Still, Io proved that moons can remain internally active for billions of years thanks to tidal heating. And that realization changed everything. Because if tidal forces can keep Io volcanically alive, perhaps they can keep water liquid elsewhere too. Europa, for instance. Suddenly scientists began looking at icy moons differently. Instead of assuming frozen surfaces meant dead worlds entirely, they considered the possibility of hidden internal oceans warmed by gravitational energy beneath the ice. In many ways, Io opened the door to some of the most exciting astrobiological questions in modern science simply by being outrageously volcanic, though admittedly, it probably did not intend to contribute academically. The moon was busy exploding. Another remarkable aspect of Io is how isolated it feels despite orbiting inside a crowded system. Sunlight at Jupiter's distance is much weaker than on Earth. The outer solar system grows dimmer, colder, quieter. Yet Io glows with internal heat instead of relying heavily on solar energy. Its activity comes from gravity, from orbital motion, from endless mechanical stress operating invisibly across space. There is something deeply strange about that. A moon heated not primarily by a star, but by the constant stretching of its own interior. If you removed Jupiter, Io would cool dramatically over time. Its volcanoes would likely fade. The moon's entire personality depends on its relationship with the giant planet nearby. In a sense, Jupiter keeps Io alive by never allowing it to relax. A rather unhealthy motivational strategy, admittedly. And despite decades of study, Io still surprises scientists. New eruptions appear unexpectedly. Surface changes continue. Some volcanic plumes reach astonishing heights. Researchers debate details of its internal structure, magma composition, and heat transport mechanisms. Even today, this small moon remains one of the most geologically fascinating places ever discovered, which says a great deal considering the solar system contains entire planets wrapped in storms larger than Earth. Yet perhaps the most remarkable thing about Io is simply this. It reminds us that worlds do not need to resemble Earth to be active, dynamic, and extraordinary. For centuries, people unconsciously treated Earth as the template for understanding planets and moons, oceans, atmosphere, mountains, weather, stable surfaces. But Io demonstrates that the universe happily builds places operating according to entirely different rules. A moon can become a volcanic inferno through gravity alone. A frozen world can conceal an ocean. An atmosphere can freeze every night. Entire categories of possibility exist beyond ordinary human experience. And once you begin exploring the moons of the solar system, normal expectations fall apart very quickly. Far from the warmth of the sun, deep within the cold realm surrounding Jupiter, there is a moon that at first glance appears quiet. Very quiet. Its surface is pale and smooth, covered in ice bright enough to reflect sunlight better than many other worlds in the solar system. Long dark cracks stretch across that frozen shell like fractures spreading slowly through glass. There are very few mountains, very few giant volcanoes, very few impact craters compared to most moons. At a distance, Europa almost looks calm, peaceful even, which is slightly misleading, because beneath that frozen crust may exist one of the most extraordinary places humanity has ever discovered, a hidden global ocean containing more liquid water than all of Earth's oceans combined, an ocean concealed beneath kilometers of ice, warmed not by sunlight but by gravity itself. And somewhere inside those dark waters, scientists wonder whether life might already exist. Not cities, not little underwater civilizations building submarine cafes beneath the ice, probably nothing dramatic enough to star in science fiction films while making mysterious speeches about humanity's destiny. More likely microbes, tiny organisms drifting through black water near warm hydrothermal vents on the ocean floor. Small, simple life forms surviving quietly in darkness, completely unaware that another species on a distant blue world spends sleepless nights wondering if it is alone. Even the possibility changes the way you look at the universe. Europa is one of Jupiter's 4 large Galilean moons discovered by Galileo Galilei in 1610. Alongside Io, Ganymede and Callisto, it orbits the giant planet in a complex gravitational dance that has continued for billions of years, and compared to its volcanic neighbour Io, Europa seems almost restrained. Its surface temperature averages around minus 160 degrees Celsius near the equator, and even colder toward the poles. Sunlight reaching Jupiter is already far weaker than what Earth receives. On Europa, daytime would resemble a very bright overcast afternoon by terrestrial standards. The sun itself would appear much smaller in the sky. Not exactly ideal beach weather, and yet, despite the brutal cold above, scientists believe liquid water exists underneath, a lot of it. The idea first gained serious attention after spacecraft observations revealed Europa's unusual surface. Instead of being heavily cratered like many old icy moons, Europa appeared surprisingly smooth and young. Long fractures crisscrossed the ice in enormous networks. Some regions looked broken apart and shifted around before refreezing again like giant floating ice rafts. The moon did not resemble a solid, frozen rock. It resembled a dynamic shell floating atop something softer beneath. Then measurements of Europa's magnetic environment provided even more intriguing evidence. Data from NASA's Galileo spacecraft suggested a conductive layer existed beneath the surface. Salt water conveniently conducts electricity very well. Suddenly the hidden ocean hypothesis became much more convincing. Today, most planetary scientists believe Europa almost certainly possesses a vast subsurface ocean beneath its icy crust. Estimates vary, but that ocean may contain twice as much water as all of Earth's oceans combined, which feels slightly unreasonable for a moon smaller than Earth's moon. The ice shell above this ocean may range from several kilometers to perhaps tens of kilometers thick, depending on location. Beneath it, dark water likely extends downward for enormous distances before finally reaching a rocky seafloor far below. And because Europa experiences tidal heating from Jupiter's gravity, the ocean remains liquid despite the freezing temperatures at the surface. Just like Io is flexed and squeezed into volcanic chaos, Europa is flexed more gently, enough to generate internal warmth, but not enough to transform the entire moon into a sulfur-covered inferno. Instead, gravity quietly keeps an ocean alive beneath the ice. The more scientists studied Europa, the more fascinating it became. On Earth, life exists almost everywhere liquid water is present. Deep oceans, underground lakes, hydrothermal vents, frozen Antarctic regions, even inside rocks. Once biologists realized how adaptable life could be, Europa suddenly looked far more interesting from an astrobiological perspective, because the moon may possess 3 major ingredients considered important for life: liquid water, energy, chemistry. Water appears abundant beneath the ice. tidal heating and possible hydrothermal activity could provide energy, and interactions between ocean water and the rocky interior might create complex chemical environments suitable for biological processes. In other words, Europa may have conditions somewhat similar to deep ocean hydrothermal vent ecosystems on Earth. And those ecosystems on our planet are astonishing places. At the bottom of Earth's oceans, far from sunlight entirely, hydrothermal vents release mineral-rich hot water into darkness. Entire ecosystems thrive around them without depending directly on solar energy. Bacteria use chemical reactions instead of sunlight to produce energy, supporting strange communities of tube worms, crustaceans, and other organisms. Life found another way. That realization transformed scientific thinking profoundly. For a long time, sunlight seemed essential for life. Then Earth itself demonstrated otherwise, which meant Europa's hidden ocean no longer appeared hopelessly sterile by default. Now, to be clear, scientists have not discovered life on Europa. Not yet. No submarines have drilled through the ice. No alien fish have waved politely at passing spacecraft. At present, the evidence points toward potential habitability, not confirmed biology. Still, the possibility alone has made Europa one of the most compelling targets in the search for extraterrestrial life. And honestly, there is something wonderfully eerie about imagining that dark ocean. No sunlight, no blue sky, no moonlight filtering through waves, just endless black water beneath a ceiling of ancient ice, while Jupiter looms faintly beyond. The ocean itself may have existed for billions of years, entire spans of Earth's evolutionary history past, while Europa's hidden waters remained sealed beneath ice in silence. And if life ever emerged there, it would have evolved completely isolated from the surface universe. No sunrise, no stars, no seasons, only darkness, chemistry, pressure, and time. It sounds almost impossible, yet life on Earth repeatedly demonstrates extraordinary stubbornness. Organisms survive in boiling acid springs deep underground, inside Antarctic ice, near radioactive waste, and at crushing ocean depths once thought entirely uninhabitable. Microbial life in particular behaves less like a delicate miracle, and more like something determined to occupy every available environment eventually. Which is both scientifically impressive and slightly concerning if you have ever forgotten leftovers in the back of a refrigerator. Europa's surface itself tells stories about the ocean beneath. The long cracks stretching across the ice likely form because tidal stresses flex the crust continuously. As Europa moves closer and farther from Jupiter during its orbit, gravitational forces pull and distort the moon slightly, cracking the ice over time. Some regions appear especially chaotic, where broken ice blocks shifted, rotated, and refroze. Scientists suspect warmer water or slushy material from below may sometimes rise upward, weakening the surface locally before everything freezes again. The entire moon behaves almost like a giant floating ice shell over a restless hidden sea, and occasionally there may even be eruptions. Observations from the Hubble Space Telescope and other instruments suggest Europa might sometimes release enormous plumes of water vapor through cracks in the ice, spraying material into space. If confirmed fully, these plumes would provide an incredible scientific opportunity, because spacecraft could potentially sample ocean material without drilling through kilometers of ice, which is considerably more convenient than trying to build an interplanetary ice boring machine in one of the harshest radiation environments in the solar system. Because unfortunately, Europa comes with complications. Several very large complications, actually. The moon orbits deep inside Jupiter's powerful radiation belts, where charged particles trapped by the giant planet's magnetic field bombard the surface continuously. Radiation levels on Europa are intense enough to kill unprotected humans quickly and damage electronics over time. So while the hidden ocean may be one of the most promising environments for life beyond Earth, the surface itself is extraordinarily hostile. not exactly the sort of place where you would casually stop for a picnic and admire the scenery, though the scenery would admittedly be remarkable. Imagine standing on Europa's frozen plains beneath the enormous presence of Jupiter hanging overhead. The giant planet would dominate the sky completely, striped with cloud bands and glowing faintly in reflected sunlight. Cracks in the ice might stretch toward the horizon in every direction. The surface beneath your feet would likely creak and shift imperceptibly over immense timescales. And below you, perhaps tens of kilometers beneath the ice, an entire hidden ocean would move silently in darkness. One of the strangest aspects of Europa is how it changes our perspective about where life might exist in the universe. For generations, scientists focused heavily on the habitable zone around stars, the region where temperatures allow liquid water to exist on planetary surfaces. Earth fits comfortably inside our sun's habitable zone, which made sense as a starting point. But Europa sits far outside that region. Sunlight alone should not keep water liquid there. Yet tidal heating changes the equation entirely. That means habitable environments may not require Earth-like planets, orbiting at Earth-like distances from stars. Moons around giant planets could potentially host subsurface oceans throughout the galaxy. And if icy moons are common, then hidden oceans may be common too. The universe suddenly becomes filled with possible habitats tucked beneath frozen crusts, orbiting giant worlds in darkness. Entire unseen ecosystems could exist in places humanity once dismissed as lifeless ice. That realization feels almost philosophical as much as scientific. Life, if it exists elsewhere, may not resemble our expectations at all. It may flourish underground, underwater, beneath ice, far from sunlight, quietly surviving in environments we once assumed impossible. Europa also highlights how interconnected planetary systems become through gravity. Without Jupiter's immense pull, the Moon would probably freeze solid eventually. Without orbital resonances involving neighbouring moons, tidal heating might weaken. The hidden ocean depends on a delicate balance of orbital mechanics, operating continuously over billions of years. A giant planet unintentionally warming a small moon from afar through gravity alone. Space relationships are surprisingly complicated, and despite decades of research, Europa still holds enormous mysteries. Scientists debate the thickness of the ice shell, the salinity of the ocean, the nature of the seafloor, whether hydrothermal vents exist, how materials exchange between surface and ocean, whether enough chemical energy exists to support biology. Every answer generates new questions, which tends to happen whenever humans investigate something genuinely interesting. Future missions hope to learn far more soon. NASA's Europa Clipper will perform detailed flybys to study the Moon's ice shell, ocean, chemistry, and potential plumes. Instruments will map the surface at high resolution, analyze composition, and search for environments potentially suitable for life. Scientists are especially eager to understand whether ocean material reaches the surface naturally, through cracks or eruptions. If so, future missions might eventually analyze samples directly for signs of complex organic chemistry, or even biological activity. The thought is extraordinary. Within the lifetimes of people alive today, humanity may discover evidence that life exists elsewhere in the solar system. Not intelligent civilizations, perhaps. Not dramatic first contact scenarios with orchestral music and extremely confident aliens. Maybe only microbes. Tiny cells drifting through black water beneath Europa's ice. Still, even simple extraterrestrial life would change humanity forever. Because if life emerged independently twice within one solar system, once on Earth and once beneath Europa's ice, then biology may not be rare at all. It may be woven naturally into the universe wherever conditions permit. And perhaps somewhere tonight, beneath Europa's frozen shell, dark ocean currents continue moving slowly through ancient waters while chemistry unfolds in silence far below the surface. No sunlight reaches there, No human eyes have seen it. Yet, it may already contain one of the greatest discoveries in scientific history waiting patiently beneath the ice. And while Europa hides its ocean under frozen crust, another moon farther away from Jupiter decided to take an entirely different approach to becoming extraordinary. By the time scientists began studying Titan seriously, they already knew it was unusual. Not volcanic like Io, not hiding a buried ocean beneath a fractured shell like Europa. Titan seemed different in a quieter, stranger way. Even through telescopes, the moon refused to reveal its surface clearly. A thick orange haze wrapped around it completely, obscuring everything below. While most moons appear sharp and airless from space, Titan looked soft and blurry, as though someone had breathed gently onto a camera lens. For a long time, nobody knew exactly what hid underneath those clouds, and naturally, that made scientists even more interested. Because throughout the history of exploration, humans have always become deeply curious the moment something refuses to let us see it properly. Hidden islands, sealed tombs, locked doors. Mystery attracts attention almost automatically. Titan understood this instinct perfectly. Orbiting Saturn at a distance of roughly 1.2 billion kilometers from the Sun, Titan is the second largest moon in the solar system, surpassed only by Ganymede. It is larger than the planet Mercury, larger than Pluto, larger than every dwarf planet discovered so far, and unlike most moons, Titan possesses a thick atmosphere. A very thick atmosphere. In fact, the atmospheric pressure at Titan's surface is greater than Earth's. If you stood there wearing protection from the cold, and lacking the entirely reasonable desire to breathe oxygen, the air around you would actually feel denser than the air at sea level on Earth, which is deeply strange when you remember Titan exists in one of the coldest regions of the solar system. Surface temperatures average around minus 179 degrees Celsius, cold enough to freeze water into rock-hard ice, cold enough that the familiar chemistry of Earth completely changes behavior. On Titan, water is not the flowing liquid shaping rivers and seas. Water is basically geology, solid, frozen, hard as stone. Instead, another substance takes over the role normally played by water on Earth. Methane. Liquid methane and ethane flow across Titan's surface in rivers, collect in lakes, fall as rain, and evaporate back into the atmosphere to form clouds. Titan possesses an entire weather cycle, just not the one you expected. And once scientists finally saw the surface clearly, the moon became one of the most astonishing places ever discovered. The real breakthrough came from the Cassini-Huygens mission. After travelling through space for nearly 7 years, Cassini entered orbit around Saturn in 2004, while the European-built Huygens probe later descended through Titan's atmosphere toward the surface. For hours during its descent, Huygens drifted slowly downward beneath orange skies while transmitting images and data back to Earth. Scientists watched as landscapes gradually emerged from the haze, channels, plains, rounded pebbles, drainage systems resembling riverbeds. At first glance, some photographs looked uncannily Earth-like, except they absolutely were not. Because every familiar-looking feature existed at temperatures cold enough to freeze human flesh, solid almost instantly. Titan is perhaps the most alien world in the solar system precisely because it feels strangely familiar. There are clouds there, rainstorms, winds, dunes, shorelines, fog, seasonal changes. Standing on Titan would likely feel oddly recognizable in certain ways despite the completely hostile environment. The orange haze would dim sunlight into a perpetual twilight. Gravity is weaker than Earth's, only about 1/7 as strong. Combined with the dense atmosphere, that means humans wearing wings could theoretically fly simply by flapping their arms, which is one of those delightful scientific facts that sounds made up but apparently is not. Although once again, the freezing methane environment slightly limits recreational tourism possibilities. Titan's atmosphere consists mostly of nitrogen, much like Earth's, but methane plays a crucial role in its climate system. Sunlight breaks methane molecules apart high in the atmosphere, producing complex organic compounds that drift downward and contribute to the thick orange haze surrounding the moon. Some scientists suspect Titan's atmosphere may resemble conditions on the early Earth, long before life emerged here. A kind of chemical time capsule preserved in deep freeze. That possibility makes Titan especially valuable scientifically, because it allows researchers to study complex organic chemistry occurring naturally on a world without life dominating the system the way it does on Earth, and the chemistry there is remarkably rich. Hydrocarbons accumulate across the surface, complex molecules form in the upper atmosphere, lakes and seas of methane occupy polar regions, enormous dune fields stretch across vast distances near the equator. The moon feels less like a frozen rock and more like an alternate version of Earth built using different ingredients. Instead of water oceans beneath blue skies, Titan offers methane seas beneath orange haze. Instead of silicate rocks, much of the landscape consists of water ice behaving like stone. Instead of warm rainfall, hydrocarbon drizzle may fall through freezing air. Everything is familiar and unfamiliar simultaneously. And then there are the seas. Titan contains the only stable liquid seas known on the surface of any world besides Earth. That statement alone would have sounded astonishing decades ago. The largest of these bodies, Kraken Mare, spans more than 1,000 kilometers across. Radar observations revealed coastlines, islands, and complex shore features. Some regions appear remarkably smooth, suggesting calm liquid surfaces. Imagine standing beside a dark methane sea beneath an orange sky, while Saturn hangs faintly above the horizon somewhere beyond the haze. No waves crashing loudly, no seabirds overhead, no trees moving in the wind, only cold silence stretching across an alien coastline where liquid natural gas collects in enormous basins under twilight skies. Titan somehow manages to feel lonely even by cosmic standards. Yet despite the cold and strangeness, scientists find the moon deeply compelling because it demonstrates how planetary processes can emerge under entirely different chemical conditions. Weather does not require water specifically. Rivers do not require Earth-like temperatures. Complex landscapes can form anywhere. Physics and chemistry allow cycles of evaporation, precipitation, and erosion. Titan expands our understanding of what worlds can be. Its rivers carve channels through ice bedrock, using liquid hydrocarbons instead of water. Rainstorms gather and move across the atmosphere seasonally. Clouds form and dissipate. Surface liquids evaporate and return as rainfall again. An alien hydrological cycle operating with methane instead of water. And because Titan's atmosphere is thick and gravity is relatively weak, erosion occurs differently there too. Wind shapes enormous dunes composed likely of hydrocarbon particles. Some stretch hundreds of kilometers across the surface. The entire moon feels active, dynamic, and evolving despite existing in deep freeze far from the sun. One particularly intriguing aspect of Titan is the possibility of subsurface water beneath the icy crust. Although the surface remains brutally cold, scientists suspect another hidden ocean may exist deep underground, composed primarily of water mixed with ammonia. So Titan may actually possess two entirely different liquid systems, methane and ethane at the surface, water deep below, a layered world of exotic chemistry. And naturally, once scientists realized Titan contained abundant organic compounds and possibly subsurface water, questions about life followed immediately. Now, life on Titan would face enormous challenges. Temperatures are incredibly low. Chemical reactions occur much more slowly in extreme cold. Water, essential for all known Earth biology, remains frozen solid at the surface. Still, some researchers have speculated about the possibility of highly unusual life forms adapted to methane environments, not Earth-like organisms, something fundamentally different. Perhaps hypothetical cells using liquid methane instead of water as a solvent. chemistry operating slowly under freezing conditions, biological processes almost unimaginably alien compared to terrestrial life. At present, no evidence supports such organisms existing, but Titan forces scientists to ask broader questions about what life itself truly requires. How flexible can biology become? Are Earth conditions universal, or merely one example among many possibilities? Could chemistry organize itself into living systems under circumstances humans once considered impossible? Titan sits quietly in the outer solar system asking these questions beneath its orange clouds. And unlike Europa, whose hidden ocean remains inaccessible beneath thick ice, Titan openly displays much of its strange chemistry at the surface, which makes it scientifically irresistible. Future missions are already planned. NASA's Dragonfly aims to send a nuclear-powered flying drone to Titan in the coming years. Thanks to the moon's dense atmosphere and low gravity, flying there is remarkably efficient compared to Earth. Dragonfly will hop between locations, exploring dunes, impact craters, and chemically rich environments while searching for clues about prebiotic, chemistry and habitability. A flying robot exploring methane landscapes beneath alien skies. Humanity increasingly sounds like science fiction simply by describing its actual plans. Still, perhaps the most remarkable thing about Titan is how naturally it reminds us that Earth is not the template for every world. For centuries, humans unconsciously treated our planet as normal. Liquid water, blue skies, moderate temperatures, rocky continents. Titan gently dismantles that assumption. A world can possess weather, rivers, lakes, coastlines, and seasons while remaining entirely unlike Earth chemically. Familiar processes emerge from different materials under different conditions. The universe appears wonderfully adaptable in that regard. And perhaps somewhere along Titan's shores, methane rain falls softly into dark seas, while hydrocarbon waves lap quietly against frozen ice rock coastlines under dim orange light. No human has ever stood there. No living creature we know has crossed those beaches. Yet the moon continues its endless orbit around Saturn regardless, carrying rivers and clouds through darkness billions of kilometers from the sun. Far beyond the warmth of the inner solar system, past the asteroid belt, beyond Jupiter and Saturn, and even distant Uranus, there drifts a blue planet wrapped in freezing winds and deep silence. Neptune. At that distance, sunlight becomes faint and weak, reduced to a pale glow barely bright enough to resemble daytime by Earth standards. The sun itself appears tiny in the sky, more like an intensely bright star than the blazing centre of the solar system we know at home. And circling Neptune is one of the strangest moons ever discovered, Triton, a world so unusual that astronomers are fairly certain it was never supposed to be there in the first place. Most large moons orbit their planets in the same direction the planet rotates. This makes sense because planets and their moons usually form together from the same rotating disk of material early in the solar system's history. Everything tends to move in roughly the same direction, rather like leaves spinning together in a whirlpool. Triton ignored that arrangement entirely. It orbits Neptune backward. Astronomers call this a retrograde orbit, and it immediately raises suspicion because moons rarely behave this way naturally if they formed alongside their planets. Triton circles Neptune opposite the planet's rotation, suggesting something dramatic happened long ago. Something involving gravity, chaos, and probably a very bad day for whatever originally lived in Neptune's moon system. Because the leading theory is that Triton did not form around Neptune at all. Instead, Triton was likely born far away in the Kuiper Belt, the vast region of icy bodies beyond Neptune that also contains Pluto and countless frozen remnants from the solar system's formation. At some point billions of years ago, Triton wandered too close to Neptune, and Neptune stole it. Gravity can be surprisingly aggressive that way. Scientists believe Triton may once have been part of a binary system, two objects orbiting one another together through deep space. during a close encounter with Neptune, gravitational interactions disrupted the pair. One object escaped while Triton lost energy and became trapped permanently around the giant planet. Imagine drifting freely through interplanetary darkness for ages only to suddenly become gravitationally kidnapped by a massive blue world. No consultation, no warning, just eternal orbital commitment, and Triton's arrival likely caused tremendous destruction. Captured moons do not settle gently into stable orbits immediately. Triton probably disturbed or destroyed many of Neptune's original moons through gravitational chaos as its orbit evolved over time. Some may have collided with Neptune, others may have been ejected entirely into space. Triton essentially arrived like a wrecking ball in an already existing moon system, which perhaps explains why Neptune today has relatively few large regular moons compared to Jupiter or Saturn. Triton may have removed the competition, and yet despite its violent origins, the moon itself is strangely beautiful. Voyager 2, the only spacecraft ever to visit Neptune directly, flew past Triton in 1989 and revealed a world unlike anything scientists expected. The surface appeared smooth in many places, covered with nitrogen ice, water ice, and frozen carbon compounds. Vast plains stretched beneath pinkish skies. Dark streaks crossed icy terrain. Some regions resembled frozen cantaloupe skin under close inspection because of their strange textured patterns. And then Voyager discovered something extraordinary. Triton was geologically active, not volcanically active like Io with rivers of molten rock and sulfur explosions. Triton possessed something colder and arguably stranger: cryovolcanoes, ice volcanoes, because apparently ordinary volcanoes were no longer sufficiently dramatic for the outer solar system. Instead of erupting molten rock, cryovolcanoes release substances like water, ammonia, or nitrogen in icy slurries under freezing conditions. On Triton, Voyager observed dark plumes rising several kilometers above the surface, likely caused by nitrogen gas erupting upward from beneath sunlit ice layers. Imagine geysers powered by sunlight in one of the coldest places in the solar system. The surface temperature on Triton hovers around minus 235 degrees Celsius. That makes it colder than almost anywhere else ever measured. Colder than Antarctica, colder than Mars, colder than your kitchen floor during a midnight snack expedition in winter. At those temperatures, nitrogen freezes solid. Methane and carbon monoxide freeze too. The landscape becomes a realm of exotic ices behaving in ways that feel deeply unfamiliar from an Earth perspective. And yet Triton remains active despite the cold, partly because its capture by Neptune likely generated enormous internal heating long ago. Gravitational interactions during orbital evolution may have melted portions of the interior, creating enough energy to power geological processes for immense spans of time. So once again, gravity quietly transforms a moon's destiny. One particularly fascinating feature on Triton is its thin atmosphere composed mainly of nitrogen. Like Titan, Triton possesses weather and seasonal changes, though far more subtle and fragile. Sunlight warms frozen nitrogen on the surface just enough for portions to sublimate directly into gas, forming a tenuous atmosphere that changes with the seasons. At Neptune's distance from the Sun, seasons last astonishingly long, because the planet requires about 165 Earth years to complete one orbit. Imagine a single season lasting decades. Children born during Triton's summer could become grandparents before the same season returned again. Time behaves differently in the outer solar system. Everything slows, the sunlight weakens, orbital periods stretch across lifetimes. Even weather seems patient. Triton's surface also contains some of the youngest terrain observed in the solar system, indicating ongoing resurfacing processes. Impact craters remain surprisingly sparse in many areas. Scientists suspect cryovolcanism, shifting ice, and seasonal activity continue altering the landscape over time. A moon captured from deep space somehow refusing to become geologically dead despite the crushing cold. And perhaps most remarkable of all, Triton may possess a subsurface ocean beneath its frozen crust. Yes, another one. The solar system increasingly resembles a suspiciously large collection of hidden oceans wrapped in ice. Models suggest tidal heating during Triton's orbital evolution may have melted internal layers long ago. Some researchers believe portions of that ocean could still remain liquid today beneath the surface, insulated by thick ice above. If true, Triton joins Europa, Enceladus, Titan, and several other moons in hinting that subsurface oceans may be extraordinarily common. Again and again, the universe keeps placing water in unexpected places. Now, whether Triton's ocean could support life remains highly uncertain. Conditions are extreme. Energy sources may be limited compared to moons closer to giant planets. The moon's geological activity appears less intense than Europa's or Enceladus's. Still, the possibility exists, and every time another hidden ocean appears in the solar system, the broader implications grow more difficult to ignore. Perhaps habitable environments emerge far more often than humans once imagined. Not warm Earth-like surfaces necessarily. Hidden environments, buried seas, dark internal worlds protected beneath ice. Life, if it exists elsewhere, may prefer secrecy. There is also something emotionally strange about Triton specifically, because it feels like an outsider. Most moons belong naturally to their planets. Triton does not. It likely spent part of its existence wandering independently through the Kuiper belt before Neptune captured it. Even now, its backward orbit marks it as fundamentally different from Neptune's original system. A stolen world carrying the memory of another home. And in the unimaginably distant future, Triton's fate becomes even stranger, because its retrograde orbit slowly causes it to spiral inward toward Neptune over immense timescales. Billions of years from now, the moon may eventually cross the Roche limit, the distance where Neptune's tidal forces become strong enough to tear Triton apart completely. The moon could disintegrate into enormous rings surrounding Neptune, a captured wanderer ultimately destroyed by the planet that trapped it. Space can be surprisingly tragic when viewed over long enough periods. Still, at the moment, Triton remains one of the most compelling unexplored worlds in the solar system. Voyager 2 provided only a brief flyby decades ago. Since then, no spacecraft has returned. Everything scientists know comes from distant observations and that single fleeting encounter, which means countless mysteries remain unresolved. How active is Triton today? Does the subsurface ocean truly exist? How thick is the crust? How exactly do the nitrogen geysers operate? What happened during its ancient capture? And what secrets still hide beneath those frozen plains under pink skies? One day humanity will probably send another mission there. Perhaps an orbiter. Perhaps even a lander designed to survive the deep cold and study the moon directly. Though admittedly, reaching Neptune takes patience. Voyager 2 required about 12 years to arrive there using gravitational assists from multiple planets. At those distances, even radio signals need roughly 4 hours to travel one way between Earth and a spacecraft near Neptune. Conversations become impossible. Everything turns into delayed messages exchanged across immense emptiness. And perhaps that is why Triton feels so haunting compared to many other moons. It exists at the edge of the familiar solar system where sunlight fades and silence deepens. A captured object from the outer darkness circling backward beneath pale skies while frozen geysers erupt into thin alien air. A moon that should not exist where it does. A world moving against the expected order of things. And yet, despite all its strangeness, Triton is still only one example of how extreme moons can become. Compared to the giant moons of the solar system, Enceladus initially seemed almost forgettable. It is small, very small, only about 500 kilometers across, which means you could fit Enceladus comfortably inside the width of countries like France or Texas, with room left over for several inconvenient parking lots. For decades after its discovery in 1789 by William Herschel, astronomers assumed it was probably just another frozen icy moon orbiting quietly around Saturn. Cold, ancient, inactive. The sort of place spacecraft fly past politely while hurrying toward more exciting destinations. Then the solar system once again demonstrated that it enjoys embarrassing human assumptions whenever possible, because Enceladus turned out to be one of the most astonishing worlds ever discovered, and it achieved this reputation in perhaps the most dramatic way imaginable, by spraying giant fountains of water into space, not metaphorically, literally. Enormous plumes erupt continuously from fractures near the moon's south pole, blasting water vapour, ice particles, salts, and organic compounds hundreds of kilometres above the surface. These geysers are so powerful that some material escapes Enceladus entirely and spreads into space around Saturn, helping feed one of the planet's faint outer rings. A tiny moon, smaller than many countries, actively contributing material to a planetary ring system through giant ice eruptions. The universe occasionally sounds like it hired science fiction writers and then told them to stop being so restrained. The discovery happened thanks to the Cassini-Huygens mission, which spent years exploring Saturn and its moons in extraordinary detail, as Cassini approached Enceladus during flybys in the mid-2000s. Instruments detected something surprising near the South Pole. Heat. More heat than expected. Far more. Then cameras revealed long, bluish fractures cutting across the icy terrain. Scientists nicknamed them tiger stripes because of their appearance, and from these cracks giant plumes of water vapour and ice blasted upward into space continuously. Suddenly, Enceladus transformed from a minor icy moon into one of the most important astrobiological targets in the solar system almost overnight. Because where there is liquid water, scientists begin paying very close attention, and Enceladus clearly possessed liquid water somewhere beneath its frozen surface. The moon itself is brilliantly reflective, covered in fresh ice that bounces sunlight back into space so efficiently that Enceladus is one of the brightest objects in the solar system. If you stood there beneath Saturn's distant glow, the surface around you would appear dazzlingly white under sunlight, almost painfully bright against the black sky. At least briefly. You would also freeze to death very quickly. Surface temperatures can plunge below -200 degrees Celsius in many regions. The environment is brutally cold, airless and silent except for the occasional roar of erupting plumes nearby. Yet beneath all that ice lies hidden warmth. Once again, gravity is responsible. Enceladus experiences tidal heating due to Saturn's gravitational pull, combined with orbital interactions involving neighbouring moons. As the moon orbits Saturn, tidal forces flex its interior slightly, generating heat through friction. Not enough heat to melt the entire moon, but enough to maintain reservoirs of liquid water beneath the crust. And in the South Polar region especially, that internal water escapes through fractures into space in spectacular fashion. Cassini eventually flew directly through some of these plumes, essentially allowing humanity to taste material from another moon's hidden ocean without drilling through kilometres of ice, which is tremendously convenient from an engineering perspective. Building interplanetary ocean drilling equipment is difficult enough already, without adding operate in vacuum beside Saturn to the instructions. The results stunned scientists. Cassini detected water vapour, salts, silica particles, methane, carbon dioxide, ammonia, and complex organic molecules within the plumes. Some particles strongly suggested hydrothermal activity occurring on the ocean floor beneath the ice. Hydrothermal activity on a tiny moon orbiting Saturn, meaning warm mineral-rich water may interact with the rock deep inside Enceladus, much like hydrothermal vent systems on Earth's ocean floors, and on Earth, hydrothermal vents teem with life. Suddenly Enceladus became not merely interesting, but potentially habitable, maybe very habitable. In fact, many scientists now consider it one of the best places in the solar system to search for extraterrestrial microbial life. Not Mars, not Venus. a tiny icy moon spraying water into space billions of kilometers from the sun. Again, the universe appears to enjoy rewarding the least obvious possibilities. What makes Enceladus especially compelling is how accessible the ocean material seems compared to worlds like Europa. Europa's ocean remains buried beneath thick ice, making direct exploration extremely difficult. But Enceladus helpfully ejects samples from its interior into space continuously through the south polar plumes. It is essentially doing scientific outreach voluntarily. Spacecraft can analyze these particles without landing or drilling. Future missions may even search directly for biosignatures, chemical indicators potentially associated with life, simply by flying through the plumes with advanced instruments. Imagine discovering alien microbes because a moon accidentally sneezed ocean water into a passing spacecraft. Scientific history can unfold in remarkably strange ways, and the hidden ocean itself appears surprisingly extensive. Researchers believe a global subsurface ocean likely exists beneath much of Enceladus's icy crust, though thickness varies regionally. Near the South Pole, the ice shell may become relatively thin, allowing water to escape upward through fractures. The ocean is probably salty, possibly warm in places, potentially active at the seafloor. Some estimates suggest hydrothermal vents there could release energy and minerals into the water similarly to Earth's deep ocean systems. If so, Enceladus may possess all the basic ingredients considered favourable for microbial ecosystems: liquid water, chemical nutrients, energy, time. Because this hidden ocean may have existed for immense spans of geological history, and perhaps somewhere in those dark waters beneath kilometres of ice, chemistry has been unfolding quietly for millions or even billions of years entirely unseen. No sunlight penetrates that ocean. No tides crash beneath open skies. Only darkness, pressure, warmth from below, and the constant subtle pull of Saturn shaping the moon from afar. There is something wonderfully eerie about that image. A tiny white moon drifting through the cold outer solar system, while deep beneath its surface an invisible ocean moves slowly in darkness. And every so often, the moon exhales pieces of that hidden sea into space. The south polar terrain itself looks unlike most icy worlds. The tiger stripe fractures cut through relatively young terrain with surprisingly few impact craters. Ice blocks and ridges surround the region. Heat measurements show temperatures there are significantly warmer than surrounding areas, though warmer remains relative in a place this cold. Still extremely unpleasant by ordinary human standards. One fascinating aspect of Enceladus is how active such a small moon remains. Small worlds usually cool relatively quickly over cosmic timescales because they lose internal heat faster than larger planets or moons. Yet Enceladus somehow continues powering major geological activity despite its modest size. Scientists still debate exactly how the moon maintains enough energy internally to sustain the plumes over long periods. Tidal heating clearly contributes, but details of the energy balance remain complex and not entirely solved. The moon continues challenging models even now, which seems increasingly common among the solar system's most interesting objects. Another remarkable discovery involved tiny silica grains found within the plumes. These particles likely formed through interactions between hot water and rock, at temperatures possibly exceeding 90 degrees Celsius on the ocean floor. That strongly suggests hydrothermal vent activity. And once hydrothermal vents enter the conversation, astrobiologists become very difficult to calm down. Because some theories about the origin of life on Earth propose that hydrothermal environments may have played a crucial role in early biology. Mineral-rich warm water systems provide chemical gradients and energy sources potentially favourable for complex organic chemistry. If similar environments exist on Enceladus, the moon may possess conditions surprisingly suitable for microbial ecosystems, despite existing in one of the coldest regions of the solar system. Not because sunlight warms it, not because it resembles Earth, but because gravity and chemistry quietly created an ocean beneath the ice. Again and again, the solar system reveals that life-friendly environments, may emerge in places humanity never originally expected. And Enceladus does all of this while remaining incredibly small. That may be the Moon's most charming quality scientifically. Giant planets are expected to be dramatic. Massive worlds naturally attract attention. But Enceladus resembles a tiny bright snowball orbiting Saturn, and somehow it ended up containing one of the most promising extraterrestrial oceans ever discovered. The universe has a wonderful tendency to hide extraordinary things inside modest packages. If you stood on Enceladus near the South Polar region, the experience would feel surreal beyond description. Saturn would dominate the sky enormously, its rings stretching overhead in breathtaking arcs. The ground beneath your feet would gleam with fresh ice, brighter than snow under sunlight. Nearby fractures might vent shimmering material upward into vacuum while fine ice particles drifted slowly downward again. Gravity would be extremely weak, only about 1% of Earth's. You could leap enormous distances accidentally with minimal effort, though you would need a spacesuit, and excellent judgment, preferably both. The plumes themselves create a faint atmosphere around the Moon, though far too thin for breathing. Escaping particles spread outward into Saturn's E-ring, meaning Enceladus continuously contributes material to its planetary environment. A tiny moon quietly feeding a giant ring system, particle by particle. Even Saturn's majestic rings partly depend on hidden ocean eruptions from a frozen world far below them. Space relationships become surprisingly interconnected once you start paying attention. Future missions to Enceladus seem almost inevitable now. Scientists desperately want better measurements of the ocean chemistry, plume composition, ice shell structure, and possible biosignatures. Some proposed missions involve repeated plume fly-throughs. Others imagine landers approaching active regions near the South Pole. More ambitious concepts even include melting through the ice one day to deploy robotic submarines into the hidden ocean itself. Which sounds wonderfully simple until you remember the environment involves vacuum, radiation, freezing temperatures, communication delays, and drilling through kilometers of extraterrestrial ice. Humanity does enjoy selecting extremely challenging hobbies. Still, Enceladus remains one of the few places in the solar system where discovering alien life feels genuinely plausible within future generations. Not guaranteed, not even likely perhaps, but plausible. And that alone changes the emotional landscape of astronomy entirely. Because somewhere beneath that bright frozen surface, warm water may already contain biology, quietly existing in darkness, while Saturn turns slowly overhead. No creature there would know about Earth. No organism would understand stars or galaxies or human beings lying awake at night listening to stories about distant moons. Yet life, if it exists there, would still belong to the same universe as us. Different origin, different ocean, different world entirely, but alive. Among all the moons orbiting the planets of our solar system, one quietly holds a rather absurd record. It is bigger than Mercury, bigger than Pluto, bigger than every other moon we have ever discovered. And yet despite all of that, most people rarely think about it at all. Its name is Ganymede, a world orbiting Jupiter every 7 days beneath one of the harshest radiation environments in the solar system. At more than 5,200 kilometers across, Ganymede is so large that if it were not gravitationally trapped by Jupiter, it would likely have been classified as a full planet centuries ago. Instead, it remains labelled simply as a moon, which feels slightly unfair, especially because Ganymede turns out to be extraordinary in ways extending far beyond size alone. It has its own magnetic field, its own auroras, possibly multiple hidden oceans stacked beneath layers of ice, an interior more complex than scientists originally imagined, and a history stretching back billions of years into the chaotic formation of the solar system itself. Yet somehow it still exists mostly in the shadow of Jupiter, which admittedly is a difficult object to compete with visually. Jupiter is enormous, striped, storm-covered, and dramatic enough to dominate almost any conversation automatically. Beside it, even giant moons can seem secondary at first glance. But if Jupiter disappeared tomorrow, Ganymede would immediately become one of the most remarkable planetary bodies humans had ever observed. The moon was first discovered in 1610 by Galileo Galilei, alongside Io, Europa, and Callisto. Those 4 moons, now known as the Galilean moons, transformed astronomy permanently because they demonstrated that not everything orbited Earth. Tiny moving points beside Jupiter ended up helping dismantle humanity's old picture of the universe, and among those moons, Ganymede eventually revealed itself as the giant of the group. If you could stand on its surface, the landscape would appear frozen and ancient. Great stretches of ice and rock cover the moon, broken by enormous grooves, ridges, and impact scars formed over geological time. Some regions are dark and heavily cratered, preserving ancient terrain billions of years old. Other areas appear lighter and more complex, marked by long tectonic features where the surface once shifted and cracked. The entire moon feels like a world caught between frozen stillness and ancient activity. Unlike Io, it is not volcanically exploding. Unlike Europa, its ocean does not sit close beneath a smooth, icy crust. Ganymede is quieter, older, more massive, a giant frozen archive carrying records from the solar system's deep past. And yet beneath that calm exterior, remarkable things are happening. Perhaps the most surprising discovery came when scientists realized Ganymede possesses an intrinsic magnetic field. That may sound slightly technical at first, but it is an extraordinary feature because no other moon in the solar system has one. Only Ganymede. Magnetic fields generally require electrically conductive material moving inside a planetary body, usually involving molten metallic cores. Earth generates its magnetic field this way through movements of liquid iron deep inside the planet. Ganymede somehow does something similar. Inside this giant moon likely lies a metallic core generating its own magnetosphere, a miniature magnetic bubble embedded inside Jupiter's colossal magnetic environment, which creates astonishing visual effects. Charged particles trapped by Jupiter's immense magnetosphere interact with Ganymede's magnetic field to produce auroras near the moon's poles. Imagine faint glowing curtains of light shimmering above an icy alien landscape while Jupiter hangs gigantic overhead. Auroras on a moon bigger than planets, orbiting inside another world's magnetic storm. The solar system occasionally behaves as though subtlety would be deeply disappointing. And then there are the oceans, because naturally once scientists began studying Ganymede more carefully, hidden water appeared yet again. Researchers believe Ganymede likely contains a vast subsurface ocean buried beneath layers of ice. In fact, the structure may be even stranger than Europa's or Enceladus's. Some models suggest Ganymede's interior could contain multiple layers of oceans and ice stacked atop one another deep below the surface. An ocean club sandwich inside a moon, though admittedly far less delicious than the phrase implies. The pressure deep within Ganymede becomes enormous because of the moon's size. Scientists suspect different phases of ice form under those conditions, creating complex internal layering. Somewhere within this frozen structure, salty liquid water likely exists in substantial amounts. Again, more water than all Earth's oceans combined may hide inside another moon. At this point, the solar system increasingly resembles a conspiracy organized by hidden oceans. And once more, questions about habitability emerge. Could life exist there? Possibly. Although Ganymede's ocean may face challenges compared to Europa's or Enceladus's, because thick layers of high-pressure ice might separate the liquid water from the rocky seafloor below. That separation could limit important chemical interactions useful for supporting biological activity. Still, scientists remain deeply interested in the moon because of its size, complexity, and potential subsurface environment. And because giant icy worlds may represent a major category of planetary bodies throughout the galaxy, one fascinating aspect of Ganymede is how different it feels from Earth's moon, despite both technically belonging to the same category. Our moon is relatively dry, geologically quiet, and lacking a substantial atmosphere or magnetic field. Ganymede, by contrast, behaves almost like a miniature planet trapped in orbit around something larger. In many ways, calling it just a moon undersells the situation dramatically. Its gravity, while much weaker than Earth's, is still substantial compared to smaller moons. If humans ever explored Ganymede directly one day, walking there would feel somewhat more familiar than hopping across tiny low-gravity worlds like Enceladus. Not comfortable exactly. Still freezing. Still airless. Still catastrophically dangerous without protective equipment. But more planet-like somehow. The surface temperatures remain brutally cold, ranging roughly between -113 and -183 degrees Celsius, depending on location and sunlight. Ice dominates the landscape. Radiation near Jupiter remains a serious hazard, though Ganymede's own magnetic field offers some limited protection, compared to moons lacking magnetospheres entirely, which is rather considerate of it, honestly. The moon also possesses a very thin atmosphere composed mainly of oxygen, though not remotely breathable by humans. The oxygen exists in extremely low concentrations produced through interactions between radiation and surface ice. So technically, Ganymede has oxygen. Practically, breathing there would remain a terrible idea. Still, the presence of even a tenuous atmosphere and magnetic field helps make Ganymede feel unusually planet-like for a moon. And then there is Jupiter itself looming overhead. From Ganymede's surface, Jupiter would dominate the sky enormously, appearing many times larger than our moon appears from Earth. Cloud bands, storms, and shifting atmospheric patterns would remain visible constantly. The giant planet would cast faint reflected light across the icy landscape even during local night. One can only imagine how psychologically overwhelming that sky would feel. A massive striped world hanging overhead permanently, while auroras shimmer near the horizon above frozen plains stretching endlessly outward. And all of it existing inside a radiation-filled environment where invisible charged particles race through space at dangerous energies. Beautiful, magnificent, absolutely lethal. The moon's geological history also tells scientists important stories about the early solar system. Ganymede likely formed alongside Jupiter billions of years ago from material orbiting the young gas giant. Over time, differentiation separated heavier materials inward and lighter icy layers outward, creating the complex internal structure observed today. Ancient impacts scarred portions of the surface heavily, while tectonic processes later reshaped other regions into grooved terrain unlike anything seen on our moon. Some of those grooves stretch for thousands of kilometers across the surface, gigantic frozen records of internal stress and crustal movement preserved over immense timescales. And despite all this complexity, Ganymede remained surprisingly mysterious for much of human history, simply because it is so far away. Even through telescopes, details remain difficult to observe clearly from Earth. Most major discoveries came from spacecraft missions like Voyager 1, Voyager 2, and especially the Galileo spacecraft, which spent years studying Jupiter and its moons in detail during the 1990s and early 2000s. Those missions transformed Ganymede from a distant point of light into a real world with layered ice, magnetic fields, hidden oceans, and geological history, and humanity is not finished exploring it. The European Space Agency's JUICE mission is currently travelling toward Jupiter specifically to study Ganymede, Europa, and Callisto in much greater detail. Remarkably, JUICE is expected eventually to become the first spacecraft ever to orbit a moon other than Earth's moon directly when it enters orbit around Ganymede itself. That alone says something important about how scientists now view these worlds. Not minor side objects, not planetary accessories, entire environments worthy of dedicated exploration. And perhaps that shift in perspective is one of the most meaningful lessons moons keep teaching humanity. The solar system is not organized into important planets, surrounded by irrelevant debris. Some of the most scientifically rich and surprising places orbit quietly around larger worlds. Moons possess oceans, weather, volcanoes, atmospheres, magnetic fields, potential habitats. In many cases, they may prove more interesting than planets themselves. Ganymede embodies that realization perfectly. A moon larger than planets, a frozen giant with hidden oceans, a magnetic world circling beneath Jupiter's colossal storms, and yet, despite its immense size and complexity, it remains strangely calm compared to some neighbouring moons. Io erupts violently. Europa hides mysterious oceans close beneath cracking ice. Ganymede feels older, steadier, more patient somehow. A giant, silent companion carrying billions of years of history beneath frozen crusts. Among Jupiter's great moons, Callisto is often the quiet one. Io steals attention by exploding constantly. Europa fascinates scientists with hidden oceans and possible life. Ganymede impresses everyone simply by being enormous enough to bully smaller planets emotionally. And then there is Callisto, dark, ancient, heavily cratered, drifting silently through space as though entirely unconcerned with competing for attention at all. Which is a shame, really, because Callisto may be one of the most important time capsules in the solar system. While many worlds were resurfaced by volcanoes, tectonic activity, erosion, oceans or shifting ice, Callisto mostly remained unchanged for billions of years. Its surface preserves scars from the distant past in astonishing detail, like a frozen archive recording the violence of the early solar system. If Earth is a constantly rewritten book, and Io is a page currently on fire, then Callisto is more like an old library no one has touched for ages, dusty, quiet, full of history, and remarkably intact. At first glance, Callisto appears rather gloomy compared to Jupiter's brighter, icy moons. Its surface is dark grey and brownish, covered in ancient impact craters layered over one another in enormous overlapping patterns. Some regions are so densely cratered that it becomes difficult to distinguish individual impacts clearly, because new craters formed atop older ones repeatedly over immense spans of time. It is one of the most heavily cratered objects in the entire solar system, which immediately tells scientists something important. The surface is extremely old, probably around 4 billion years old in many places. That means Callisto avoided the large-scale resurfacing events that transformed many neighbouring worlds. No global volcanic renewal, no dramatic tectonic recycling, no widespread ice shell overturning. The moon simply accumulated impacts slowly while orbiting Jupiter through cosmic history. And because of that stillness, Callisto preserves evidence from an era long vanished elsewhere. The early solar system was chaotic beyond ordinary imagination. Young planets migrated, asteroids collided constantly, giant impacts reshaped worlds repeatedly. Debris filled space in staggering quantities. During a period called the Late Heavy Bombardment roughly 4 billion years ago, impacts may have hammered many planetary surfaces relentlessly. Earth experienced this violence too. Mars did. The Moon certainly did. But geological activity erased much of Earth's oldest evidence long ago. Plate tectonics, erosion, oceans and weather continuously recycle our planet's surface. Callisto, however, remained mostly frozen and inactive. So the scars stayed. The Moon became a giant frozen memory. One of Callisto's most famous features is the Valhalla Impact Basin, an enormous multi-ring structure stretching nearly 4,000 kilometers across. It is among the largest impact structures ever discovered anywhere in the solar system. Imagine an asteroid impact so colossal that shock waves fractured the crust outward into concentric rings, spanning much of an entire moon. Valhalla resembles a gigantic bullseye frozen into the surface, and it is not alone. Another major basin called Asgard lies nearby, also surrounded by vast circular ridges formed by ancient impacts. The landscape across Callisto looks almost overwhelmed by the accumulated violence of deep time. Yet strangely, despite all those catastrophic events, the moon feels calm now, still, frozen, as though the chaos exhausted itself billions of years ago and left only silence behind. Callisto orbits farther from Jupiter than the other large Galilean moons, and that distance shaped its destiny profoundly. Unlike Io and Europa, which experience intense tidal heating because of strong gravitational interactions with Jupiter and neighbouring moons, Callisto avoided most of that internal stress. Jupiter never squeezed it hard enough to keep the interior dramatically active, so the moon cooled, quieted, settled into geological old age. And because tidal heating remained relatively weak, scientists originally assumed Callisto was probably simple internally too, just ice and rock mixed together without much complexity. Naturally, the moon eventually complicated that assumption as well, because evidence now suggests Callisto may also contain a subsurface ocean buried beneath its ancient icy crust. At this point, hidden oceans are becoming almost suspiciously common. Measurements from the Galileo spacecraft indicated the presence of a conductive layer beneath the surface, possibly a salty liquid ocean lying deep underground. If confirmed fully, Callisto would join the growing family of ocean worlds scattered throughout the outer solar system, though unlike Europa or Enceladus, Callisto's ocean may lie much deeper beneath the surface and experience far less internal heating, which makes the moon scientifically intriguing in a different way. Europa feels dynamic, Enceladus feels active, Callisto feels ancient. Its hidden ocean, if present, exists beneath a surface preserving billions of years of solar system history almost undisturbed. And despite the immense age of its terrain, the moon itself remains surprisingly large. At roughly 4,800 kilometers across, Callisto is nearly the size of Mercury. Yet because it orbits Jupiter, rather than the Sun directly, it remains categorized as a moon instead of a planet. Again, the distinction begins to feel slightly arbitrary once objects reach these scales. If you stood on Callisto's surface, the experience would differ dramatically from standing on Earth, or even on some neighbouring moons. The sky would remain black at all times because the moon lacks any substantial atmosphere to scatter sunlight. Jupiter would loom enormous overhead, though not quite as overwhelmingly large as seen from closer moons like Io. The landscape around you would appear ancient beyond comprehension. Crater walls, frozen plains, endless overlapping scars stretching toward the horizon. No wind, no rain, no oceans moving beneath open skies, just silence preserved across geological ages. And unlike Europa or Io, Callisto resides mostly outside Jupiter's most intense radiation belts. That detail has made the moon particularly interesting for long-term exploration concepts, because radiation exposure there would be far less severe than on moons closer to Jupiter. In fact, some scientists have suggested Callisto could potentially serve as a future base location for human missions exploring the Jovian system, which admittedly sounds exciting right up until you remember less radiation than Io is not necessarily the same thing as pleasant. Still, compared to Europa's deadly radiation environment, Callisto appears comparatively manageable. Its relative distance from Jupiter offers a kind of quiet safety, while still providing access to the broader Jovian system. And because the moon possesses abundant water ice, future explorers might theoretically extract resources there for fuel, life support, or construction. Humanity has an impressive tendency to look at frozen alien wastelands and immediately begin discussing infrastructure possibilities. One particularly fascinating aspect of Callisto is how undifferentiated parts of its interior may remain. Unlike fully separated worlds where dense materials sink inward cleanly while lighter layers rise outward, Callisto may preserve a more mixed internal structure in some regions. That suggests the Moon never heated enough during formation to fully separate internally like larger active worlds. In a sense, Callisto froze before finishing development completely. A giant world suspended partway between formation and full planetary complexity. And because it remained relatively unchanged, scientists value it enormously as a record of early solar system conditions. Crater distributions reveal information about ancient impact populations. Surface chemistry preserves clues about radiation exposure and icy materials over billions of years. Callisto is less dramatic than Io, less mysterious than Europa, less imposing than Ganymede. But it may be one of the best preserved historical documents in the solar system, a frozen archive orbiting Jupiter quietly while younger worlds around it evolved more dramatically. And perhaps there is something strangely comforting about Callisto's stillness. Many worlds in the solar system are violent places. Volcanoes erupt, storms rage, ice cracks, radiation sweeps through space. Planetary atmospheres churn continuously. Entire surfaces reshape themselves over time. Callisto mostly endured, impact after impact after impact, then silence, billions of years of silence. There is no weather there to soften the craters, no rivers to erase the scars, no forests or oceans or winds. Time accumulates visibly across the landscape instead of hiding itself beneath geological recycling. Standing there would likely feel emotionally overwhelming in ways difficult to describe. Human beings rarely encounter places untouched for even thousands of years, let alone billions. Yet Callisto preserves terrain older than complex life on Earth itself, older than trees, older than dinosaurs, older than oxygen-rich atmospheres, a moon carrying memories from near the beginning of the solar system. And despite its ancient appearance, scientists continue discovering surprises there too. Surface chemistry remains complex. Subsurface structure remains debated. The possibility of an ocean continues attracting attention. Some regions show subtle signs of past tectonic activity or internal evolution. Even quiet worlds refuse to become entirely simple once humans investigate them carefully enough. Future missions to Jupiter will likely study Callisto further alongside Europa and Ganymede. The European Space Agency's JUICE will perform flybys helping scientists understand its composition, geology, and possible subsurface ocean more clearly. And perhaps one day, far in the future, humans themselves may stand on Callisto's frozen plains looking outward toward Jupiter, hanging enormous in the darkness, while ancient craters surround them in every direction. A remarkably old landscape beneath a giant planet, a moon that spent billions of years quietly remembering. For a long time, humanity thought of Pluto as the lonely edge of the solar system. A tiny frozen world drifting in darkness far beyond Neptune, so distant and dim that even large telescopes revealed little more than a blurry point of light. It became famous partly because it was mysterious, and partly because everyone enjoyed memorizing planets in school before astronomers arrived with complicated reclassification decisions and emotionally destabilized educational posters. Then things became even stranger, because Pluto was not alone. Orbiting beside it was a moon called Charon, and unlike most moons in the solar system, Charon was so large relative to Pluto that the two objects behaved less like a planet and moon system, and more like twin worlds trapped together gravitationally forever. Most moons are tiny compared to their planets. Earth's moon is large relative to Earth, certainly, but Earth still dominates the system comfortably. Jupiter's moons, despite their impressive sizes, remain small beside the giant planet they orbit. Charon changes the balance entirely. It is roughly half the diameter of Pluto. Massive enough that the centre of gravity between the two objects, called the barycenter, does not actually lie inside Pluto at all. Instead, it exists in empty space between them. That means Pluto and Charon technically orbit each other together. a cosmic dance between two frozen worlds locked face to face permanently. And once you picture that arrangement properly, it becomes wonderfully strange. If you stood on Pluto's surface, Charon would hang enormous in the sky, fixed almost motionless overhead depending on your location. It would not rise or set normally, because Pluto and Charon are tidally locked to one another. Each world always shows the same face to the other, forever. Every orbit takes about 6.4 Earth days, and during all that time, Pluto and Charon remain locked in constant mutual staring, which is either deeply romantic or slightly unsettling depending on your personal preferences regarding gravitational relationships. The system itself exists incredibly far from the Sun, deep within the Kuiper Belt, where sunlight becomes weak and pale. At Pluto's average distance, daylight is dimmer than on Earth by a factor of roughly 1,500. The Sun appears like an exceptionally bright star rather than a dominating presence in the sky. Yet despite the cold and darkness, Pluto and Charon turned out to be far more active and complex than scientists expected. As usual. Before NASA's New Horizons spacecraft arrived at Pluto in 2015, after a journey lasting nearly a decade, many researchers expected a relatively simple frozen world. Ancient, cratered, geologically dead. Instead, New Horizons revealed landscapes that looked astonishingly diverse. Towering water ice mountains, nitrogen glaciers, layered atmospheric hazes, possible cryovolcanoes, smooth plains with surprisingly few impact craters. Pluto, despite its tiny size and immense distance from the Sun, refused to behave like a frozen relic. And Charon turned out to be fascinating too. The Moon's surface differs dramatically from Pluto's in both colour and terrain. Charon appears greyer overall, with giant canyons stretching across portions of the landscape. Some of these fractures form one of the largest known canyon systems in the solar system. Imagine cracks so enormous they dwarf Earth's Grand Canyon casually. Again, outer solar system moons tend to overachieve once humans examine them closely. One particularly striking feature on Charon is its dark reddish polar region nicknamed Mordor Macula, because apparently planetary scientists occasionally become extremely honest about their literary inspirations. Scientists believe this dark material may form through a wonderfully strange process involving Pluto itself. Methane escaping from Pluto's atmosphere drifts across space toward Charon, where it freezes onto the cold polar regions. Sunlight and radiation then chemically alter the methane over time, creating complex reddish organic compounds called tholins. In other words, Pluto is slowly painting Charon's pole red from a distance. The two worlds remain connected not only gravitationally but chemically as well, and despite their small sizes, both objects show evidence of surprising geological complexity. Pluto especially shocked scientists because parts of its surface appear relatively young. The enormous heart-shaped region called Sputnik Planitia contains smooth nitrogen ice plains with very few craters, suggesting active resurfacing occurred relatively recently in geological terms. At temperatures around minus 230 degrees Celsius, familiar materials behave very differently. Nitrogen, methane, and carbon monoxide can exist as ices that slowly flow across the landscape, like glaciers under Pluto's weak gravity. Water ice there behaves more like bedrock because it remains extremely hard at such low temperatures. Entire alien geological systems operate using frozen gases instead of liquid water or molten rock. The farther humans explore the solar system, the more chemistry itself seems to rearrange into unfamiliar versions of nature. And beneath Pluto's icy crust, scientists even suspect a subsurface ocean may once have existed, or perhaps still exists today in some form, naturally. Because hidden oceans are apparently the solar system's favourite surprise. Some evidence suggests Pluto may possess an internal layer of liquid water insulated beneath the surface by radioactive heating and thick ice above. If true, it would mean even distant dwarf planets in deep freeze can maintain internal complexity for billions of years. Charon, meanwhile, likely experienced internal freezing and expansion long ago, potentially helping create its enormous surface fractures. As internal water froze and expanded, the crust may have cracked apart dramatically. A moon literally splitting itself open while orbiting beside Pluto through darkness. And perhaps the most emotionally strange thing about Pluto and Charon is how isolated they feel. Jupiter's moons exist within crowded systems filled with giant planets, radiation, and neighbouring worlds constantly influencing one another. Saturn's moons drift among rings and complex gravitational interactions. Pluto and Charon exist far beyond all that, quietly orbiting each other in the dim outskirts of the solar system where sunlight weakens into distant twilight. The nearest large planet lies billions of kilometres away. Space around them feels emptier somehow, colder, more patient. And because Pluto's orbit is highly elliptical, conditions there change slowly over immense spans of time. One complete orbit around the Sun takes 248 Earth years. Seasons last decades. Atmospheres partially freeze onto the surface and later sublimate back into gas again depending on orbital position. Time moves differently that far out. Entire human generations pass during a single Plutonian season. Imagine being born during winter on Pluto and dying before summer fully ended. The scale of the outer solar system quietly humbles ordinary human intuitions about time. Yet despite their remoteness, Pluto and Charon became deeply important scientifically because they revealed how diverse Kuiper Belt objects could be. Before New Horizons, the outermost regions of the solar system remained largely mysterious. Scientists knew icy objects existed there, but details were limited. Pluto and Charon transformed from distant abstractions into real places with landscapes, weather, processes, geological history, and active chemistry. And once again, a supposedly minor world turned out to be astonishingly complicated. One remarkable feature of the Pluto-Charon system is how stable their tidal locking arrangement became. Over time, gravitational interactions synchronized both bodies completely. Pluto always shows the same hemisphere toward Charon, and Charon always shows the same face toward Pluto. Permanent mutual orientation, an eternal gravitational partnership. No sunrise or moonrise from certain regions because the companion world simply hangs motionless in the sky forever. There is something hauntingly beautiful about that image. Two frozen worlds facing each other continuously across empty space, while orbiting together through darkness for billions of years. And yet, despite the poetic appearance, the system formed through violence. Scientists believe Charon likely originated after a giant impact early in Pluto's history, similar in some ways to theories about Earth's moon formation. A massive collision blasted material into orbit around Pluto, eventually gathering into Charon. Catastrophe, creating companionship once again. The solar system repeats that pattern often. Impacts destroy, gravity rebuilds, worlds emerge. The more scientists study Pluto and Charon, the more the distinction between planet and moon began feeling somewhat blurry. Charon is too large relative to Pluto to behave like a typical moon. The barycenter lies outside Pluto entirely. Some researchers informally describe the system as a binary dwarf planet arrangement rather than a simple moon system, which feels reasonable honestly. If two worlds orbit one another around a point floating in empty space between them, calling one merely a moon begins sounding slightly inadequate. Still, classifications matter less than the underlying reality, and the reality is this. Deep in the outer solar system, two frozen worlds remain locked together gravitationally in one of the most unusual orbital relationships ever discovered. A double-world system drifting beneath weak sunlight at the edge of the sun's domain. Some moons look majestic, some look dangerous, some look ancient, frozen, volcanic, or mysteriously oceanic. And then there is Hyperion, which looks as though the universe attempted to build a normal moon, became distracted halfway through, and simply decided, good enough. Orbiting Saturn among its many icy companions, Hyperion is one of the strangest shaped objects in the solar system. Instead of forming a smooth sphere like larger moons do under their own gravity, Hyperion resembles a giant irregular chunk of porous ice covered in deep craters. Most people immediately compare it to a sponge, and honestly, the comparison is difficult to improve upon. Its surface is filled with enormous pits and cavities, giving the moon an appearance somewhere between volcanic pumice, Swiss cheese, and an object that perhaps should not be touched without protective gloves. The moon itself is relatively small, only about 270 kilometers across at its widest point, and its gravity is extraordinarily weak. If you somehow stood on Hyperion and jumped enthusiastically in the wrong direction, you might genuinely risk drifting away from the surface entirely. Careful walking would become less a matter of balance, and more a matter of remaining politely attached to the moon. And yet, despite its odd appearance, Hyperion becomes even stranger once you examine its motion. Most moons rotate in predictable ways. They spin steadily while orbiting their planets, often becoming tidally locked over time so the same face always points toward the planet they orbit. Hyperion refused to cooperate with that arrangement entirely. Instead, it tumbles chaotically through space, not metaphorically, actually chaotically. Its rotation changes unpredictably because Saturn's gravity and the gravitational influence of nearby Titan constantly disturb it. Rather than spinning smoothly like Earth's moon, Hyperion rotates irregularly, wobbling and tumbling in ways that make long-term predictions extremely difficult. If you lived on Hyperion, assuming you somehow solved the minor issues involving vacuum and non-existent gravity, the sky would behave bizarrely. Saturn would appear in different positions unpredictably. The sun would rise and set at irregular angles. Orientation itself would become confusing over time. The moon behaves less like a stable world and more like a cosmic object that never quite settled down properly. And perhaps the most fascinating thing about Hyperion is how empty it is internally. Its density is incredibly low, suggesting the moon contains enormous amounts of empty space within its structure. Scientists suspect Hyperion may be highly porous, perhaps resembling a loosely compacted rubble pile more than a solid body. Imagine a moon made partly of gaps and voids, held together gently by weak gravity. That unusual structure probably explains why its craters look so strange. On denser worlds, impacts blast material outward forcefully and create flatter crater floors. Hyperion's porous surface absorbs impacts differently, leaving deep, sharp-edged pits instead. Some craters contain dark, reddish material gathered at their bottoms, creating eerie contrasts against the brighter ice surrounding them. Scientists think this material may consist of hydrocarbons or complex organic compounds accumulating over time. So even Hyperion's craters look unsettlingly mysterious. The moon itself likely formed from fragments produced during ancient collisions elsewhere in Saturn's system. Over time, gravity pulled debris together loosely into the irregular object we see today. But because Hyperion remained relatively small, gravity never became strong enough to compress it into a sphere fully. It simply stayed lumpy forever. There is something oddly charming about that. Most large objects in the solar system eventually surrender to gravity's demand for roundness. Hyperion somehow escaped the pressure by remaining small and porous enough to preserve its awkward shape. A cosmic exception drifting around Saturn like an unfinished idea. And despite its bizarre appearance, scientists value Hyperion because it demonstrates how diverse moons can become, depending on size, composition, impacts, and gravitational interactions. Not every moon evolves into a neat spherical world with stable rotation. Some become tumbling sponge-shaped oddities barely held together at all, and once you think the solar system cannot possibly become more unusual, another moon arrives and somehow manages exactly that. Because orbiting Uranus is a moon called Miranda that looks less like a normal celestial body and more like several unrelated worlds accidentally stitched together. Miranda is not large, only about 470 kilometers across. Yet its surface contains some of the most extreme terrain ever discovered on any moon. Gigantic cliffs, patchwork regions with completely different appearances, massive canyons, ancient cratered plains abruptly interrupted by younger bizarre structures. At first glance, Miranda barely looks geologically coherent at all, and that led scientists to a wonderfully dramatic theory. Perhaps the moon was once shattered apart completely and later reassembled itself, which sounds deeply unreasonable until you actually look at the terrain. The discovery came from Voyager 2 during its 1986 flyby of Uranus. Before Voyager arrived, Miranda appeared merely as another tiny distant moon. Then close-up images returned to Earth, and scientists collectively experienced what was essentially geological confusion. Parts of Miranda looked ancient and heavily cratered. Other sections appeared much younger. Enormous cliff systems cut across the landscape unexpectedly. One cliff called Verona Rupes may rise around 20 kilometers high, making it possibly the tallest known cliff in the solar system. 20 kilometers. Mount Everest would fit inside that drop with room remaining. Standing near the edge would likely feel psychologically offensive to ordinary human instincts. And then there were the coronae, strange oval-shaped regions with ridges, grooves, and unusual textures unlike surrounding terrain entirely. They looked almost pasted onto the moon afterward. The surface appeared broken into mismatched sections, as though someone assembled Miranda from spare parts. Scientists eventually proposed that giant impacts early in the moon's history may have shattered it partially or completely. Gravity then pulled much of the debris back together into a reconstructed moon. A cosmic demolition followed by reluctant reassembly. And remarkably, the theory is not impossible. Small moons experience relatively weak gravity. Massive collisions can disrupt them dramatically, without necessarily dispersing all material permanently into space. Fragments may eventually fall back together over time. Miranda may literally be a rebuilt world, though alternative explanations also exist involving intense tectonic and thermal activity, driven by tidal heating in the past. Uranus and neighbouring moons may once have gravitationally stressed Miranda enough to partially melt its interior, causing strange resurfacing processes and massive geological deformation. Either way, the result is extraordinary. A moon with one of the most chaotic-looking surfaces ever observed. And unlike Hyperion's soft, sponge-like weirdness, Miranda's strangeness feels violent, broken, reshaped, scarred by catastrophic history. If you stood on Miranda, the landscape would likely appear almost surreal. Towering cliffs would dominate portions of the horizon. Sharp ridges and deep trenches would cut through the icy terrain. Vast regions would look completely different from neighbouring areas only a short distance away. The moon would not feel unified visually. It would feel assembled. And because Uranus itself rotates tipped sideways compared to most planets, the entire Uranian system experiences unusual seasonal lighting conditions over long periods. During parts of its long orbit around the Sun, regions of Miranda may experience decades of darkness, followed by decades of sunlight. Again, the outer solar system quietly abandons ordinary Earth expectations whenever convenient. Miranda also highlights an important truth about moons generally. Small size does not guarantee simplicity. In fact, some of the most bizarre worlds discovered so far are relatively small moons shaped by unusual histories. Giant planets attract attention naturally because of their scale, but moons often preserve stranger geological stories. Hyperion became a tumbling porous sponge. Miranda became a shattered and rebuilt patchwork world. Enceladus sprays oceans into space. Io erupts constantly. Europa hides seas beneath ice. The category Moon turns out to contain astonishing diversity. And perhaps that is partly because moons live complicated lives gravitationally. They are pulled, squeezed, captured, shattered, heated, frozen, and reshaped by nearby giant planets, continuously over billions of years. Planets dominate, moons adapt, sometimes beautifully, sometimes catastrophically, sometimes in ways so strange that scientists initially struggle to explain what they are seeing at all. For most of human history, moons existed only in our own solar system. People looked upward and saw Earth's moon glowing above them, while astronomers gradually discovered additional moons circling Jupiter, Saturn, Uranus and Neptune through telescopes over the centuries. Eventually, spacecraft have visited those distant worlds directly, revealing volcanoes, frozen oceans, methane rainstorms, and landscapes stranger than anyone had expected. And then astronomy took another enormous step outward, because once scientists confirmed the existence of planets orbiting other stars, an obvious question followed almost immediately. If planets exist elsewhere, then where are their moons? The answer is almost certainly everywhere. And yet, strangely enough, exomoons remain some of the most difficult objects in astronomy to detect. Planets around distant stars are already incredibly challenging to observe. Compared to their stars, planets are tiny, dark, faint objects lost inside overwhelming stellar brightness. Detecting them often requires indirect methods like watching for tiny dips in starlight during planetary transits, or measuring subtle, gravitational wobbles in the host star itself. Now imagine trying to detect a moon orbiting one of those already difficult to detect planets. A moon around a planet around a distant star. The observational challenge becomes almost absurd, and yet astronomers keep trying because moons may be extraordinarily important in the universe, possibly even more important than planets in some cases. There may be billions of them, trillions perhaps, entire hidden populations of alien moons orbiting giant worlds across the galaxy, while humanity strains to glimpse even a few hints of their existence. The research itself feels slightly like trying to identify individual fireflies circling distant lighthouse beams from across an ocean. Still, over the last couple of decades, astronomers have found tantalizing clues suggesting exomoons are real and potentially enormous. One of the most discussed candidates involves a possible moon orbiting the exoplanet Kepler 1625b. Observations from the Kepler Space Telescope and later the Hubble Space Telescope suggested the presence of a Neptune-sized moon orbiting a giant planet, a moon the size of Neptune, which immediately demonstrates how differently planetary systems elsewhere may behave. In our solar system, moons remain smaller than planets by comfortable margins, but around distant stars entirely new categories of moon systems may exist. Giant moons orbiting super Jupiters, rocky moons circling gas giants within habitable zones, worlds larger than Earth, permanently illuminated by reflected light from colossal nearby planets hanging overhead. And perhaps somewhere out there, moons more habitable than the planets they orbit. That possibility has fascinated scientists for years. Imagine a giant gas planet orbiting inside the habitable zone of its star, warm enough for liquid water to exist. The gas giant itself might lack a solid surface entirely, but large moons orbiting it could potentially possess atmospheres, oceans, climates, and stable environments suitable for life. Entire Earth-like moons around giant alien planets. The idea sounds wonderfully cinematic. Night skies dominated by enormous striped worlds overhead, while stars drift across alien atmospheres. Tides driven by massive nearby planets. Eclipses occurring constantly as giant worlds block starlight. And unlike isolated planets, such moons would receive energy from multiple sources simultaneously. Sunlight from the host star, reflected light from the nearby planet, tidal heating generated by gravitational flexing. A moon orbiting a giant planet might remain geologically active for billions of years, even in regions where ordinary planets would freeze. Again and again, moons expand the possible locations where life might emerge. Some scientists even argue that habitable exomoons may outnumber habitable planets eventually. Because giant planets appear extremely common throughout the galaxy, and wherever giant planets form, Moons often follow. Of course, life on an exomoon might experience profoundly different conditions from life on Earth. Take tides, for example. On Earth, the moon creates ocean tides that shape coastlines and marine ecosystems. But on a large exomoon orbiting close to a giant planet, tidal effects could become much stronger. Oceans might rise and fall dramatically. Internal heating from gravitational stress could drive extensive volcanism or maintain subsurface oceans. Some exomoons may resemble giant versions of Europa or Enceladus. Others might experience perpetual volcanic activity like Io, and some could possess thick atmospheres and weather systems unlike anything in our solar system entirely. Then there are the truly extreme possibilities. Astronomers have discovered giant exoplanets orbiting astonishingly close to their stars. Some complete entire orbits in only a few days. These worlds become intensely heated, with atmospheric temperatures reaching thousands of degrees Celsius. Now imagine moons orbiting those planets. If such moons exist and remain gravitationally stable, they may experience extraordinary conditions. Tidal forces could become immense, radiation levels brutal, entire surfaces might partially melt under constant heating. Some exomoons may possess magma oceans stretching beneath black skies, while nearby giant planets dominate the heavens overhead. Others may orbit planets around red dwarf stars where one side of the moon experiences eternal daylight, while another remains locked in perpetual darkness. The diversity of possibilities becomes almost overwhelming, and because astronomers still struggle to detect exomoons clearly, much of this remains theoretical for now. But theory in astronomy often has a habit of becoming reality eventually once technology improves enough. After all, exoplanets themselves were once hypothetical. Now scientists know thousands exist. The methods used to search for exomoons are remarkably delicate. One major approach involves studying tiny irregularities in planetary transits. If a planet passes in front of its star from our perspective, it blocks a small amount of starlight. A moon orbiting that planet could slightly alter the timing or brightness pattern of the transit. The changes are minuscule, incredibly tiny. Astronomers measure fluctuations so subtle that the process feels less like observation and more like cosmic detective work. And because data can be noisy and ambiguous, confirming exomoons remains difficult. Many candidate detections stay uncertain for years while scientists debate interpretations carefully. Still, most researchers agree on one important point. Exomoons almost certainly exist. Too many planets exist for moons not to emerge naturally as part of planetary formation processes. Gravity builds systems repeatedly throughout the universe. Stars gather planets. Planets gather moons. Some moons may even gather smaller moonlets occasionally. Cosmic nesting dolls assembled by orbital mechanics. One especially fascinating possibility involves rogue exomoons. Worlds once orbiting planets, but later ejected into interstellar space entirely through gravitational interactions or catastrophic events. These moons would wander alone between stars without any sun at all. At first glance, such worlds sound hopelessly frozen and lifeless. But perhaps not. If a rogue moon retained enough internal heating through radioactive decay or tidal interactions before ejection, subsurface oceans might survive beneath thick insulating ice layers for immense spans of time. A dark, wandering moon carrying hidden oceans through interstellar space without any star nearby. The universe keeps producing environments stranger than expected every time humans attempt to categorize it neatly. Another curious possibility involves moons around rogue planets themselves. Some giant planets may drift through the galaxy unattached to any star, carrying their own moon systems into darkness. Imagine skies without a sun, no sunrise, no daylight, only starlight and the looming presence of a giant planet overhead while hidden oceans move beneath frozen crusts. It sounds less like astronomy and more like a dream someone has after falling asleep during a physics lecture. Yet nothing currently known in physics forbids such worlds from existing. And perhaps the most emotionally strange realization about exomoons is this: many may already contain histories unfolding completely beyond human awareness. Somewhere right now, alien moons likely circle giant planets beneath unfamiliar stars. Storms move through their atmospheres, ice cracks, volcanoes erupt, oceans shift beneath frozen shells, seasons change over decades or centuries, entire worlds living out their histories silently, while humanity remains barely capable of detecting their existence at all. It is a humbling thought, especially because moons in our own solar system already taught us how deceptive appearances can be. For centuries, moons seemed secondary, minor companions beside more important planets. Then spacecraft arrived and revealed volcanoes, oceans, atmospheres, weather cycles, magnetic fields, hydrothermal chemistry, and geological complexity. If our own moons proved so astonishing up close, what might exist around distant stars? Perhaps ocean moons larger than Earth. Perhaps worlds permanently illuminated by giant ringed planets overhead. Perhaps moons with ecosystems beneath ice. Perhaps places where life emerged entirely independently under conditions humans have never imagined. The galaxy suddenly feels less empty once you begin thinking in terms of moons instead of planets alone. And yet, despite all these extraordinary possibilities beyond our solar system, some of the strangest moons ever discovered remain much closer to home. Because before humanity ever finds alien exomoons directly, there are still bizarre worlds within our own solar system waiting to challenge expectations one last time. Worlds where gravity becomes so weak that landscapes barely hold together. Worlds wandering near the edge of interstellar darkness. Worlds proving that moons are not merely side characters orbiting larger planets. They are some of the most extreme, creative, and surprising places the universe has ever built. Most moons spend their lives attached to something larger. They orbit giant planets faithfully for billions of years, locked into gravitational relationships that shape everything about them. Their climates, tides, geological activity, and even internal oceans often depend on the worlds they circle. Jupiter squeezes Io into volcanic fury. Saturn warms Enceladus enough to maintain hidden seas. Neptune captured Triton and changed its destiny forever. Moons and planets usually travel together, which makes the idea of a moon wandering completely alone through interstellar space feel strangely unsettling. And yet, according to many astronomers, such worlds may actually exist. Rogue moons, objects once bound to planets, but later cast out into the darkness between stars. Entire moons drifting alone through the galaxy without a sun, without a home planet, without even daylight in any ordinary sense. At first glance, the idea sounds impossible. Surely moons need planets in order to remain moons at all. Otherwise, they simply become small rogue planets, or frozen asteroids wandering independently through space. Technically, that is partly true. Once a moon escapes permanently from its planet, the distinction becomes somewhat philosophical. But the important point is origin. These objects may have formed as moons inside planetary systems before violent gravitational events eventually ejected them outward into interstellar darkness. And the universe appears remarkably good at ejecting things. Planetary systems are not calm places during their early formation stages. Young giant planets migrate inward and outward. Orbits shift. Massive gravitational interactions fling smaller bodies around unpredictably. Some planets collide. Some spiral toward their stars. Some are thrown entirely out of their systems into deep space. Moons can suffer the same fate. Imagine a giant planet moving chaotically through a developing planetary system billions of years ago. Gravitational encounters with neighbouring worlds destabilize the system gradually. Orbits become stretched and distorted. Then eventually, during one particularly catastrophic interaction, A moon escapes its planet entirely. Suddenly it is alone. No giant world overhead anymore. No stable orbit. Just endless interstellar night stretching in every direction. And according to current theories, there may be enormous numbers of rogue worlds drifting through the galaxy already. Astronomers have discovered evidence suggesting rogue planets, planets unattached to any star, may be surprisingly common. If rogue planets exist in large numbers, then rogue moons probably do too. Because wherever giant planets formed with moon systems originally, at least some moons may have escaped during violent orbital reshuffling. The galaxy could contain countless orphaned moons wandering silently between stars, which is a deeply lonely image if you think about it too long before sleep. Still, the truly fascinating question is not merely whether rogue moons exist, it is whether they could remain active, or even habitable. Because at first glance an isolated moon drifting without sunlight sounds hopelessly frozen. Space between stars is unimaginably cold. Without solar energy, surface temperatures would plunge toward extreme cryogenic conditions rapidly. Any atmosphere would likely freeze and collapse. Surface oceans would solidify. Darkness would become permanent. And yet, once again, the universe complicates things. Because moons do not always rely entirely on stars for heat. Several moons in our own solar system already demonstrated that internal energy sources can maintain liquid water beneath thick ice shells. Europa, Enceladus, Titan, perhaps Ganymede and Callisto too. Their hidden oceans survive partly because of tidal heating and radioactive decay within their interiors. Now imagine a rogue moon that once orbited a giant planet closely enough to experience substantial tidal heating before ejection. Its interior may already contain warm subsurface oceans insulated beneath kilometers of ice. Would those oceans freeze immediately once the moon escaped into interstellar space? Not necessarily. Ice is actually an excellent insulator over large scales. Thick frozen crusts can trap internal heat surprisingly effectively. Radioactive decay within rocky interiors may continue providing warmth slowly over billions of years. Some scientists speculate that subsurface oceans on rogue worlds could potentially survive astonishingly long periods even without sunlight. A dark wandering moon carrying hidden liquid water through the galaxy entirely alone. No sunrise ever, no parent planet nearby. No star visible larger than ordinary points of light. Just frozen silence above while warm oceans move beneath the ice. It sounds less like astronomy and more like existential science fiction. Yet the physics may genuinely allow it. And if liquid water survives, then another possibility inevitably follows. Could life survive too? Now, to be clear, this remains highly speculative. No rogue moon has been directly confirmed. No hidden interstellar ecosystems have been discovered floating between stars quietly minding their own business. Still, if microbial life can emerge in subsurface oceans powered by chemistry and geothermal energy rather than sunlight, then theoretically such ecosystems might persist on isolated rogue moons as well. Life hidden beneath ice in complete darkness while drifting endlessly through the galaxy. Entire biospheres existing without any concept of a sun. That possibility changes the emotional scale of the universe dramatically, because humans instinctively associate life with stars, warmth, daylight, habitable zones, but rogue moons suggest biology, if sufficiently adaptable, may not require any of those things at all. Life could survive underground, under ice, inside darkness, far from stars entirely. The galaxy suddenly becomes much harder to classify into living and dead regions neatly. And then there's another strange possibility. What if some rogue moons still orbit rogue planets? Because if giant planets can be ejected from planetary systems, while retaining some moons gravitationally, entire wandering moon systems may drift through interstellar space together. Picture it for a moment. A giant rogue gas planet moving silently through darkness without a star. Several moons orbiting it faithfully beneath black skies. Perhaps tidal heating still operating internally. Perhaps subsurface oceans still surviving. Tiny hidden worlds circling a dark, wandering giant through the spaces between stars. No sunlight, no dawn, only distant starlight and the faint reflected glow of a nearby planet overhead. The farther astronomy progresses, the more the universe begins resembling a place where almost every imaginable environment eventually exists somewhere. One especially intriguing idea involves free-floating habitable environments surviving for billions of years independently of stars. If internal heat sources and thick ice insulation prove sufficient, rogue moons might preserve liquid oceans long after ordinary surface planets freeze completely. In some bizarre sense, buried oceans beneath rogue moons could potentially outlive the habitable eras of many normal planets orbiting stars. Stars evolve, stars die, stars expand into red giants, but deeply insulated underground oceans on wandering worlds may continue quietly for immense periods if enough energy remains trapped inside. Again, the universe seems oddly determined to keep hidden oceans alive whenever possible. Detecting rogue moons directly, however, would be extraordinarily difficult. Even rogue planets are hard enough to find because they emit little light and drift isolated through space. Astronomers occasionally detect them indirectly through gravitational microlensing, when the gravity of a dark object briefly magnifies the light of a background star during alignment. A rogue moon would be smaller, dimmer, colder, and even harder to observe. Most may remain forever invisible to us. Entire populations of wandering worlds crossing the galaxy unnoticed. And perhaps that invisibility itself feels appropriate somehow. Moons already tend to exist in shadows. They orbit larger objects quietly, while planets and stars attract most attention. Rogue moons simply take that solitude to its final extreme. No star, no planet, only darkness and motion. Yet despite the loneliness implied by such worlds, there is something strangely beautiful about them too. A rogue moon is, in a sense, ultimate independence achieved through catastrophe. Once part of a system, now wandering freely forever, and perhaps somewhere tonight, beyond the reach of any nearby star, one such moon drifts silently through interstellar space beneath a frozen crust kilometers thick. Above the surface, darkness stretches endlessly. Below, hidden oceans move slowly through warm black water. Maybe chemistry unfolds there quietly. Maybe nothing lives there at all. Maybe entire ecosystems survive beneath the ice, completely unknown to the rest of the galaxy. The truth is, humanity still knows remarkably little about what exists between the stars. And that uncertainty itself may be one of the most comforting things about astronomy. The universe remains unfinished from our perspective, unexplored, full of possibilities still waiting in darkness. Because every time humans assumed they understood where worlds could exist, moons appeared in stranger places. Every time scientists assumed life required specific conditions, nature hinted at alternatives. And every time astronomy tried to simplify the cosmos into neat categories, reality produced something wonderfully unreasonable instead. A tumbling sponge moon, a volcanic inferno, an ocean beneath ice, a moon with methane rain, a captured world orbiting backward, a double planet system locked together forever, and perhaps, somewhere far beyond all of them, lonely moons wandering through interstellar night, carrying hidden oceans silently across the galaxy. When human beings first began studying the night sky seriously, planets naturally received most of the attention. They moved across the heavens differently from stars. They appeared brighter, stranger, important somehow. Entire civilizations tracked their motions carefully, built myths around them, named gods after them, and eventually sent spacecraft to visit them. Moons, meanwhile, seemed secondary. Companions, decorations orbiting larger worlds. Interesting perhaps, but not central to the story. And for a while, That assumption felt reasonable enough. After all, planets dominate visually. Jupiter overwhelms the sky with its size. Saturn carries magnificent rings. Neptune glows deep blue in distant darkness. Even tiny Pluto became culturally beloved simply because it occupied the mysterious outer edge of the solar system for generations. Yet the deeper humanity explored space, the stranger the situation became. Because again and again, moons turned out to be the places where many of the most extraordinary discoveries were hiding. Not planets, moons. A volcanic world erupting endlessly because gravity squeezes it constantly. A frozen moon concealing oceans larger than all Earth's seas combined. A tiny icy sphere spraying water into space from beneath its crust. A world with methane rainstorms and hydrocarbon lakes. A captured moon orbiting backward. A tumbling sponge-like object barely held together by gravity. A double-world system locked together forever. And perhaps countless hidden moons elsewhere throughout the galaxy, waiting beyond current technology. Somehow, the secondary objects became some of the most scientifically important places in the universe, and maybe that shift tells us something larger about reality itself. Because moons repeatedly challenge human assumptions in ways planets often do not. For centuries, people unconsciously treated Earth as the template for understanding worlds generally. Oceans on surfaces, atmospheres, continents, stable climates, daylight, weather systems based on water, geological activity powered mainly from within planets themselves. Then the moons arrived and quietly dismantled those expectations one by one. Io showed that gravity alone could transform a moon into a volcanic nightmare. Europa suggested oceans might survive beneath kilometers of ice. Titan demonstrated that rivers, rain, and seas do not require water at all. Enceladus proved tiny frozen worlds could hide active hydrothermal oceans. Triton showed captured moons could remain geologically alive in extreme cold. Again and again, moons revealed that the universe is much more flexible and creative than humans originally imagined. And perhaps the most important lesson involves life itself. For a long time, the search for extraterrestrial life focused heavily on Earth-like planets orbiting within habitable zones around stars. The logic made sense. Earth was the only known example of a living world, so scientists naturally searched for similar environments elsewhere. But moons complicated that picture enormously. Because Europa and Enceladus may possess habitable oceans despite existing far outside the Sun's traditional habitable zone. Tidal heating from giant planets can maintain liquid water independently of sunlight. Hidden oceans beneath ice may persist for billions of years in darkness. Suddenly, life no longer seemed restricted to warm planetary surfaces. It could survive underground, under ice, inside buried oceans, perhaps even on rogue moons wandering between stars. The universe became filled with potential habitats hidden where humanity never originally thought to look, and that realization carries enormous implications. Because if life can emerge in subsurface oceans powered by chemistry and gravitational heating, rather than direct sunlight, then habitable environments may be vastly more common than previously believed. Every giant planet system could potentially host ocean moons. Every ocean moon becomes another possible biological experiment conducted by the universe, and there may be billions upon billions of such worlds throughout the galaxy. The odds change dramatically once moons enter the conversation. Even within our own solar system, moons may ultimately become more important to astrobiology than planets themselves. Mars remains scientifically fascinating, certainly, but Europa and Enceladus increasingly attract attention as potentially more promising locations in the search for current extraterrestrial microbial life. Think about how strange that would sound to someone living a century ago. Humanity once imagined Mars covered with alien civilizations and canals, while moons seemed irrelevant by comparison. Now scientists seriously discuss hidden ecosystems beneath icy crusts orbiting giant planets. reality consistently refuses to follow human storytelling preferences neatly. And moons matter for another reason too. They reveal how interconnected planetary systems actually are. Our own moon stabilizes Earth's axial tilt, helping maintain long-term climate stability. Without it, Earth's seasons and climate patterns might vary much more chaotically over geological time. Some researchers believe the moon played a crucial role in creating conditions favourable for complex life here. In other words, life on Earth may partly owe its existence to a moon. Not merely the planet itself, and elsewhere in the universe, similar relationships may shape countless worlds. Giant planets may stabilize or destabilize neighboring systems gravitationally. Moons may influence tides, climates, internal heating, atmospheres, and geological activity across immense spans of time. Planetary systems are not isolated objects floating independently. They are dynamic gravitational ecosystems. Everything influences everything else. Moons also preserve history in remarkable ways. Callista carries records from the ancient solar system across billions of years of impacts. Earth's moon preserves evidence from early geological eras long erased from our own planet. Captured moons like Triton contain clues about ancient migration and chaos in the outer solar system. Some moons are geological archives, others are active laboratories, some are both simultaneously, and perhaps that diversity is what makes them emotionally compelling too. Planets often feel complete somehow, self-contained, dominant. Moons feel relational, connected. They orbit, interact, respond to gravity constantly. Their stories become intertwined with larger worlds in complicated ways. Europa exists because Jupiter squeezes it. Enceladus erupts because Saturn flexes it. Triton was captured and transformed by Neptune. Charon and Pluto orbit each other almost as equals. Moons remind us that celestial objects do not exist independently from one another. Gravity ties them together continuously across space and time, and in a strange way that feels very human. Nothing truly exists alone for long. Everything influences something else eventually, even across billions of kilometers. Another remarkable thing about moons is how they repeatedly force scientists to revise expectations. Almost every major moon explored closely turned out stranger than anticipated. Titan gained methane weather systems. Io erupted volcanically beyond imagination. Europa hinted at oceans. Miranda looked shattered and rebuilt. Hyperion tumbled chaotically. Enceladus sprayed hidden seas into space. The pattern became difficult to ignore. Moons are where the solar system hides some of its best surprises, and perhaps that should not have been shocking in hindsight. Moons occupy unusual positions physically. They exist between categories in many ways, not fully independent planets, not merely debris either. They experience intense gravitational influences from nearby giants, while remaining worlds in their own right. That combination creates fascinating possibilities. Too small to behave like planets, too large to remain simple rocks. Moons live in the strange middle ground where complexity thrives, and the more scientists study them, the more they begin resembling entire worlds deserving attention equal to planets themselves. In fact, the distinction between planet and moon occasionally becomes blurry altogether. Ganymede is larger than Mercury. Titan possesses a thick atmosphere. Charon forms a binary-like system with Pluto. Some exomoons may potentially exceed Earth in size. At what point does a moon stop being just a moon? The universe does not appear particularly concerned with human categories. It simply builds worlds. And perhaps the greatest lesson moons teach us is humility. Again and again, humanity underestimated them. Again and again, they revealed unexpected complexity. The solar system once seemed relatively simple from far away, planets surrounded by minor satellites. Then spacecraft arrived, and every moon became its own story. A volcanic inferno, a buried ocean, a frozen archive, a methane world, a wandering captured object, a hidden sea beneath the ice, a tumbling sponge, a shattered moon rebuilt from catastrophe, the universe suddenly became less orderly and far more interesting. And somewhere tonight, while Earth rotates quietly beneath its familiar moon, countless other moons continue their endless journeys elsewhere. Europa's buried ocean still moves beneath frozen crusts. Titan's methane clouds still drift across orange skies. Enceladus still sprays water into space around Saturn. Triton still circles backward through deep cold around Neptune. Farther out, Pluto and Charon remain locked together beneath weak sunlight. And beyond our solar system, alien moons likely orbit giant worlds under unfamiliar stars completely unnoticed by humanity for now. Some may possess oceans, some may carry atmospheres, some may already contain life. Entire hidden worlds may fill the galaxy, while human beings lie awake at night, wondering whether the universe is empty. It probably is not. And perhaps that is the quiet comfort hidden inside all these strange moons. The cosmos appears far more alive with possibility than it once seemed, not necessarily crowded with advanced civilizations or dramatic science fiction empires. Maybe nothing so grand, but oceans beneath ice, chemistry unfolding in darkness, geological energy persisting for billions of years, conditions where life could emerge quietly and stubbornly. Possibility itself becomes widespread, and the deeper humans explore, the more the universe seems to whisper the same message repeatedly. Do not assume ordinary appearances tell the whole story. A frozen moon may hide an ocean. A tiny world may contain extraordinary chemistry. A seemingly unimportant object may turn out to matter enormously. And perhaps people are not so different. After all, some of the most important things in existence are hidden beneath surfaces too. Quiet thoughts, memories, dreams, potential. The solar system's moons spent centuries appearing distant and secondary, while concealing astonishing worlds underneath. Only when humanity looked closer did their true complexity emerge, and somewhere far above Earth tonight, our own moon continues drifting silently through darkness beside us, as it has for billions of years. Familiar, ancient, still shaping the tides while countless stranger moons orbit elsewhere in the universe beyond sight. Quiet companions of the cosmos, not lesser worlds, just worlds humanity had not learned how to appreciate properly yet.